Hello everyone, good morning. Welcome to day 3 of this program. We'll give a couple of minutes for our friends to join in. All right. Good morning everyone. Let us do a quick recap of what we have discussed until now. We have started with Python basic commands, some packages in Python, and then basic statistics. Then we went on to discuss regression analysis. Yesterday we discussed logistic regression. My question is, if there is already regression, which is kind of linear regression, why there is a need of logistic regression? Why can't we simply apply linear regression everywhere? What is the need of logistic regression? In which specific scenario logistic regression is used? When the problem statement is classification, when it comes to classification or classification problems, linear regression fails, we have to use logistic regression. Okay, we build logistic regression model. How do you validate the logistic regression model? How do you validate? What is the validation metrics for logistic regression? For all classification algorithms, validation is done using confusion matrix and accuracy. Then we went on to discuss decision trees. Decision trees is another type of classification algorithm, but they are used for customer segmentation because decision trees give, apart from classification prediction, apart from giving a prediction of 0 or 1, they also give us the customer segments as the output. Decision trees are specifically used for customer segmentation. However, while working with decision trees, we need to be extra careful because decision trees are little dangerous. Decision trees are more very flexible that they memorize the whole data. They have that power. That's why while working with decision trees, we have to be little extra careful. Decision trees are very much prone to the problem of what is the problem that we need to be aware of or we need to be careful with when we are working with decision trees. We need to be careful when we have the problem of overfitting. Decision trees are prone to overfit, or if the tree is too small, then they are going to go to underfit as well. But as usual, what we do is we don't finalize the model when it has lesser accuracy. Overfitting is a very big problem. If we leave it to default parameters, then we get into overfitting. To avoid overfitting, we need to cut short the trees. What is that process called? Adjusting the tree so that we can avoid overfitting. That is called pruning. Pruning is performed by using pruning parameters. What are the pruning parameters? What are the pruning parameters? Max depth is one of the pruning parameter. What's the other pruning parameter? Max leaf nodes. Is it okay if we leave these pruning parameters to default values? Are we going to get a good decent model if we leave it to default values? Is it a good idea? No, it is definitely not a good idea. If we leave these parameter to default value, the tree will be too large. So by default, your decision tree will be what? If you leave it to default values, what are you going to get? Are you going to get an error? No, you will not get error. But what will you get? You will obviously get a very large tree which is overfitted. So we have to adjust them to make it to the optimal values. Okay. That's what we have discussed until now. In these topics, whatever we have discussed until now, please let me know if you have any questions. All right. If there are no questions, then we are going to discuss one more algorithm called cluster analysis. Whenever I am introducing a new algorithm, first we have discussed about regression. It is used for a particular type of problems, especially when the output is continuous. Then I have introduced logistic regression. We learned about logistic regression. There is a specific reason why we needed another algorithm because there are some problems where regression is not able to solve. That's why we have introduced logistration. Then we learned about decision trees. There is a kind of segmentation problem where logistic regression is not useful. Decision trees are much more useful. Definitely, There are a certain type of problems where cluster analysis, this clustering it is known as cluster analysis, is going to solve some problems that cannot be solved using regression, logistic regression, decision tree. These three could not solve. That's why we needed another algorithm called cluster analysis, which works perfectly for a certain type of problem. So when I explain this cluster analysis, we are also going to discuss where are the places where you must apply a cluster analysis. But these three algorithms, are you aware when to use which algorithm? All of you, let me ask you a few questions. Let's say you want to run a marketing campaign. You want to take the whole data. I gave you the whole data, and then you want to apply a particular strategy for a particular set of people. Are you going to use linear regression, logistration, or decision trees? Which one are you going to use? You want to run a marketing campaign for a particular set of people, you want to apply a strategy. For a particular set of people, you want to apply another strategy. For a particular set of people, you want to apply another strategy. That means we want to take the whole customers and then we want to divide them into sets. Which algorithm helps us in that? If we want to divide the customers into groups or subsets, then decision tree is useful. Like that, depending on the problem statement, we have to see which is the one that suits best for our problem. Okay. Dividing into sets, by default, it will be decision trees. Let us see what does cluster analysis do and where is it used. Until now, whatever data we have used, it looks like this, isn't it? The rough skeleton of the data looks like this. We have feature 1, feature 2, feature 3, and so on, feature k, target variable y. Sometimes the target variable is continuous. Sometimes the target variable is classification like 0 or 1. Using all the features, I want to predict whether this transaction is fraudulent or non-fraudulent. Using all the features, I want to predict whether this customer will respond or not respond. Using all the features, I want to predict the sales in a particular region. Using all the features, I want to predict the number of users in a particular region. So this was the whole type of data that we have seen until now. Sometimes what happens is we have only features data available. Historical values of the target, this value is not available. Why is not there? Only features data is there. For example, we have a new client in the market, let's say MG Hector. Their cars they are selling. They have launched newly in India. What they have done is they want to do some kind of customer segmentation because they want to do the marketing. So they want to do the customer segmentation. Basically, for a particular set of customers, they want to take their car and they want to give the demo. Imagine they have downloaded the data of 1 lakh customers, something like LinkedIn or something. They went to LinkedIn, they paid some money, and they got the data for 1 lakh customers. What do you think? These social networking websites, do they protect our private data or do they sell it? What do you think they generally do? Websites like Facebook, LinkedIn, WhatsApp, do they sell it or do they protect us? Like, are they really going to help us? Without any hesitation, not even a single bit of consideration. Ruthlessly, they sell it. Do you agree with that point? All these social media website, wherever some good service is given to us freely, I think a lot of you are aware of it, isn't it? Everybody is saying yes, they will sell it. That's what the reality is. So we just pay some money to Facebook or LinkedIn or any other social networking website, Twitter or Instagram. They will sell all the details, everything that they have, they can sell. Even if you say pay some extra money, they will even give the password if required.
I mean,
Yeah.
nowadays we can programmatically use APIs to bulk
Hmm.
get the data also.
Correct. Yes. So that is almost like free data is a kind of Twitter. You can get like 250 or something. But if you pay money, like without any hesitation, they'll give.
Yeah.
Imagine MG Hector went to LinkedIn and they gathered 1 lakh customers data. So I know each customer. These are kind of 1 lakh potential customers. So I know each customer age, I know each customer designation, whatever details I can get from LinkedIn, what is the place that, what is the city he is living in, which company is working and what is the years of experience, based on his designation, what is the estimated income, etc., etc. Nearly 200, 300 features. I have got the details for every customer. Nearly 1 lakh customers. All these around 200 features are available, small, big, all types of features. But what we don't have is this first customer, whether he has purchased MG Hector or not, whether second customer, whether he has purchased our car MG Hector or not, that is not there. Historically, whether this person has purchased or not, this information is not available in LinkedIn, isn't it? Very rarely somebody will post something like, I have just purchased a car which is MG Hector. Generally, people don't do such kind of posts, isn't it? That's the reason why we do not know what is the value of target variable. These are all the potential customers. Now, what MG Hector tells us is, obviously, I cannot go to these 1 lakh customers. Obviously, I cannot give a demo to each of these customers. Definitely, it takes nearly 3 to 4 hours for me to send a customer along with this, to send an agent along with the car and showing the demo, taking a test drive. It almost takes half a day. So 1 lakh customers is too high a number to try everybody. What I want to do is I want to do customer segmentation. I want to do customer segmentation. After that, I want to study each segment, and then choose a particular segment of customers that are most probable for buying this car. Instead of choosing 1 lakh, maybe I'll focus on these 1,000 guys only, or maybe I'll focus on these 500 or 1,000 or 2,000 people only. I want to do the customer segmentation and choose the perfect segment which is suitable for my car. Okay. And then I'll try to maybe call them, I'll try to give them a demo or something. That is the overall problem statement. Whenever you think of customer segmentation, which algorithm should come to your mind? What is the algorithm that you're going to use for customer segmentation? For customer segmentation, we should use decision tree algorithm. Decision tree takes the whole data, divides it into customer segments. But can we apply decision tree on this data? For applying decision tree, how do you make the data into splits? You have to use the, what is the measure that we use? Tell me in decision trees, if I want to choose the variable for splitting, what is the criteria that variable must have? So if I have this data, I want to make it into two splits. I have so many variables. So which variable I'm going to choose here? Think about it, try to recollect. There are so many variables, x1, x2, and so on. We will use the variable that has the maximum information gain, isn't it? Maximum information gain. For calculating information gain, we need entropy. For calculating entropy, we have that P1, probability of class 1, probability of class 2. That means target variable Y must be available, isn't it, for a decision tree to be effective? Do you agree with that point? For calculation of information gain, we need entropy. For calculation of entropy, we need probability of class 1, probability of class 2. But do we have class 1, class 2 segregated here? Do we know what is the target variable Y here in this data? Think about it. If you do not have Y variable, can you apply a decision tree? As the decision tree theory support, if there is no target variable, we cannot apply a decision tree if there is no target variable. I want to do customer segmentation. I have an algorithm ready for it. We have already discussed in depth of it. But this algorithm requires target variable. If there is no target variable, decision tree cannot be applied. Its theory doesn't support. Decision tree does not work. Because decision tree, the whole theory is about purity, isn't it? Pure buyers, pure non-buyers. But who is buyer, who is non-buyer? That thing is given here, isn't it? There is no measure of purity, there is no measure of impurity like entropy. You cannot calculate it. Decision tree cannot be applied if you have not target variable. Not only decision tree, what about regression? Do you think regression requires target variable, or without target variable we can build a regression line? What do you think? What is the regression equation? Y equal to beta naught plus beta 1x, which means x and y both are required. Yes or no? Regression also requires the target variable. What about logistic regression? What about logistation? Does it require target variable or it doesn't require target variable? Can it work without target variable? Registration also y equal to e power beta naught plus beta 1x divided by 1 plus e power beta naught plus beta 1x. This one also requires target variable. These algorithms work only when there is a target variable available. Otherwise, they cannot be applied. Their theory doesn't support. These type of algorithms that work only when there is a target variable available, they are known as supervised machine learning algorithms. What are the supervised machine learning algorithms? The algorithms that work only when there is a target variable available. This target variable is also known as label. So you're labeling first customer as 0, second customer as 1, third customer as 0, fourth customer as 0, fifth customer as 1. This is label. These algorithms work only on the labeled data. Until now, all the algorithms that we have discussed, linear regression is a supervised machine learning algorithm. Logistic regression is a supervised machine learning algorithm. Decision trees is a supervised machine learning algorithm. But now we have non-labeled data. We have only X variables, features are available, target is not available. Our client MG Hector, if we talk to them, they don't understand all these jargons. If we tell them there is no target, only you have given features, critical data is missing, actually they will laugh at us. You know what they will say? They will blame us, saying that I have given you 1 lakh data points, I have given you 200 columns, and you are worried about single column. What is this? That's what the clients are going to tell us. It is true that sometimes you will get that kind of response saying that we have given you large amount of data. For a client, data means these rows and columns. They don't really distinguish what is a feature, what is a target variable, and all that. Still, we have to do the customer segmentation and provide them the segments. How do you do this customer segmentation here? Is there any algorithm that work when there is no target variable available? Can we still make this into segments? Can we still make this into customer segments even without target variable? Yes, there is an algorithm called cluster analysis, clustering or cluster analysis. This works even when there is no target variable available. Cluster analysis algorithm is known as unsupervised machine learning algorithm. What is unsupervised machine learning algorithm? A machine learning algorithm that works even when there is no label, even when there is no target variable. Have you now understood the difference between supervised machine learning, unsupervised machine learning algorithm? Overall, what is a supervised machine learning algorithm? An algorithm that works only on the labeled data, only when there is a target variable available. An unsupervised machine learning algorithm works even without a target variable. Target variable is a very special variable. Even without that, we will be able to build the cluster analysis. So what is the main objective in clustering? What is our objective here? Today we are discussing this session. What is the objective here? Take the whole data as input. Take the whole data as input. Divide this data into segments in such a way that customers who are falling in the same segment are similar to each other. Customers who are falling in two different segments are very distinct, very different from each other. That's why they are falling in two different segments. Otherwise, they should have, like, if this customer is same as this customer, they both should have been in the same cluster. So customer segmentation is what we want to do. Customer segmentation, we want to divide this data into customer segments. Each segment is known as cluster here. In this terminology, each segment is called as cluster or a subset. Tell me, for customer segmentation, decision trees are used. For customer segmentation, clustering is used. Can we use them interchangeably? Are they exactly same? Is this just an alternative of decision tree? Or what is the main difference? Try to highlight once again. What is the main difference? Can we use them interchangeably? No. The main difference is clustering is a unsupervised machine learning algorithm where there is no target variable available. Decision tree is a supervised machine learning algorithm. It requires target variable. If I have the target variable, I don't even consider clustering. I'll directly go to decision trees. But if I do not have the target variable, then I have to use this unsupervised machine learning algorithm, which is clustering algorithm. So if you ask me what are the applications of clustering, The same applications of decision tree are the same applications of clustering. Clustering is used in market segmentation, target marketing. Okay, before sending a marketing campaign, I want to do the segmentation, sales segmentation. Before devising a sales strategy, I want to divide the customers into segments. Operation segmentation, high performers, low performers, operation segmentation. Insurance segmentation, I want to divide the whole customers into groups, decide a particular premium for each group. These are all the applications of decision trees as well. However, we have to be careful. Decision tree is not a simple alternative of cluster analysis. There is a huge difference. What is that huge difference? Cluster analysis is an unsupervised machine learning algorithm. In this session now, if you have to work with non-labeled unsupervised data in future, how cluster analysis is going to be applied, how it gives us these target segments is what we are going to discuss here. Okay. So what is the input? Full data is the input. What is the output? Dividing the data into segments. These customers fall in segment 1 or cluster 1. Usually segment is known as cluster here. These customers fall in cluster 2. These customers fall in cluster 3. Similar customers should be here. Dissimilar customers should be in two different clusters. Put all the similar guys at one place. The distinct guys should be at other place. First of all, I have to define what is similarity, isn't it? We have to get a clarity on when I say two customers are similar to each other. What do you mean by similarity? When do you say these two customers are similar? First, we need to quantify it. We need to define it without any ambiguity, isn't it? When I say this is customer one, this is customer two, are they similar? Are they dissimilar? First, we need to measure it. So, how do you quantify dissimilarity or similarity? Let us first understand that. Quantification is important. Imagine you are a bank manager and you have received three loan applications from customer 1, customer 2, and customer 3. And you have only one variable, one feature. You are aware of their only one feature, that is their income. If you are looking at these applications and if I ask you, tell me out of these three, who are the two similar customers? What will be your answer? Who are the two similar customers out of these three? What do you think is your answer? What will you say? You will look at the data. You look at each feature of the customer. Right now, there is only one feature available, which is income. You'll be comparing their income. It looks like customer 1 and customer 2 are similar to each other. If I have two variables, let's say if I have given you two variables, I have given their income as well as number of loans. Then what will you do? You will process both the columns. You'll process the information of income. You will also consider loans feature. Based on both of them, you are going to decide who are the two customers who are similar. Imagine I have given you income feature as well as I have told you what are their loans, number of loans. Now, can you tell me who are the customers who are similar to each other in general sense? You know the income. Imagine you are the bank manager. You are now looking at these three applications. And my question to you is, tell me who are the customers? Which two customers are similar to each other? What do you do? You try to process income along with the number of loans. Then try to think who are the customers who are similar to each other. Here, it seems that 1 and 3 are the customers because both of them may have same income. But if I am the bank manager, if I am looking at these applications, definitely this guy will be a far away guy from these two. Do you agree with that point? They may have the same income, but somebody with 7 loans along with this income definitely will be far away from these two people. So how is that achieved in mathematics is like this. Look at this. What we have done, the way we have processed the data internally is this is what we have done. We have imagined these as points and this point is far away from the rest of the points. Imagine this first axis is income axis. X-axis is income axis. Income can be 50,000. Income can be 100,000. Income can be 25,000. Income can be 75,000. This is income axis. The second axis is number of loans axis. Number of loans can be 2, number of loans can be 4, number of loans can be 6, number of loans can be 8, 10 like that. Now look at it. If you have these two as axes, if you have income and number of loans as axes, each of these customer will be a point on this coordinate plane. You can actually take this customer 1, you can put him as a point on this plane. Can you make a guess where will this customer fall? Customer 1. You can actually put him as a point. Is this customer 1? Check that. Can I say this is where the customer 1 will be falling? Make sense? 68,000 roughly. And then his number of loans are 0. So y-axis value will be 0. Similarly, I can also put customer 2. Can you make a guess where will this customer 2 fall in? Somewhere here, but the number of loans are 7. He is the guy who's customer 2. Somewhere slightly here and then here. This is customer 2. Where does customer 3 fall in? Again, he will be on the x-axis only. This is customer 3. Customer 1, customer 2, customer 3 can be points on this plane if you imagine each of the feature as the axis. Customer 1, customer 2, customer 3. If you have 2 points in coordinate geometry, you can always find the distance between the 2 points, the straight line distance. If you have a point x1, y1, if you have another point x2, y2, there is a formula for calculating the distance from here to here. You know what is distance? Simply if you take tape, put it here, from here to here, if you measure how much ever is the length or the distance, that will be nothing but the distance. So the distance d between point x1, y1, x2, y2, do you remember the formula? Distance d. It will be square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the distance between any given 2 points. That means if you measure it with tape, you will get this number. Okay. Now tell me, if the distance d is high, does that mean those two customers are similar or dissimilar? If the distance is high, is that an indication of similarity or dissimilarity? It indicates that those two customers are much more dissimilar, isn't it? If two customers are similar, the distance d will be what? If I'm saying this customer looks very similar to this guy, so when I calculate the distance d between them, what will I get? Will it be a higher value or a lower value? If a customer is absolutely perfectly same as the other guy, then the distance d will be 0. Otherwise, I'll get a lower distance, isn't it? If the customers are for similar customers, isn't it? Now that is with only 2 columns, income and number of loans. What about I have another column? Let's say that other column is expenses, which means I have x-axis, y-axis and z-axis is also there. It is possible. X-axis, y-axis, z-axis. The first point will be x1, y1, z1. The second part will be x2, y2, z2. So you have 3 axes. This is the third axis, income, number of loans, and then some other value is there. Okay. Third column is also there. Number of loans or amount of loan. Yeah. Like that, you can have several columns. Imagine the third column. The first point will be x1, y1, z1. The second point will be x2, y2, z2. What is the distance d between 2 points where x1, y1, z1, x2, y2, z2 is there? That means imagine a room, the room that you are sitting in. Imagine a point towards the corner of the room. Imagine another point towards you. If you have 2 points like this in 3D, if you take tape and measure the distance between them, the formula for calculating that distance in mathematics is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Is it possible that there is one more feature also available for a customer? I know his number of loans, income, expenses. Is it possible for one more feature to be present? It is very much possible. A customer can be having several features. X1, Y1, Z1, K1 is the fourth feature. X2, Y2, Z2, K2 is another feature. We cannot draw beyond 3 dimensions. But in mathematics, multiple dimensions do exist. Between these 2 points, what is the formula for distance calculation? It is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square plus k2 minus k1 whole square. It doesn't matter how many dimensions are there, how many ever features are there. You can always find the distance between two customers. Then you can compare it with distance of, let's say, C1 with C2. You can always compare it with C1 and C3. You can then tell whether C1 is close to C2 or whether C1 is close to C3. You can always tell which whether this customer is similar to C2 or much more similar to C3. That can be calculated no matter how many features are there. Mathematically, it is possible to quantify it. This distance d, more formally known as Euclidean distance. This Euclidean distance will tell us whether the customers, whether the points are closer or similar to each other or not. Okay. That is just the theory. What we will do is we will do one more small example to understand this further. Because until now we worked with the data set only. For us, how does the data set look like? For us, until now, we worked with the data. Inside the data set, let's say you have customer 1, customer 2, customer 3, customer 4, and so on, customer n. N customers are there. Then you have feature 1, feature 2, feature 3, and so on. Let's say P features are there. X1, feature 1, X2, feature 2, X3, and so on, P features. So the shape of our input data is always n cross p. There are n rows, p features or p columns are there. Here there is no target. Okay. Now what we are interested in is whether customer 1, what is his distance from C2, C3, C4, C5, Cn. So customer 1 I'll take, and for from him to everyone else, customer 1, customer 2, customer 3, and so on, customer n. I'll take customer 2. I want to find the distance of customer 2 from C1, C2, C3, Cn. Customer 3, his distance from everybody else. Like that, customer n, his distance from everyone else. This is kind of data matrix or data set. This is distance matrix. This will give the distance from everybody to everyone else. Can you make a guess what will be the shape of distance matrix? How many rows and how many columns? Data matrix is n cross p. N customers, n rows, p features. What will be the shape of the distance matrix? Every customer, his distance from every other customer. It will be n cross n. How many ever rows are there? Those many ever columns will be there. N cross n. This is the data matrix. This is the distance matrix. This distance matrix will be later analyzed. There is something called cluster analysis algorithm. That algorithm will look at this distance matrix and then do the rest of the steps to make the clusters. So that clustering, we will reach there a little later. First, we will try to understand this distance somewhat much more deeper. So I have taken another small data set to understand this distance further. So in the next exercise, what we are going to do here is I'm taking a small data set. This is not a original data set. I have simulated this data for this example. Later on, the example that we are taking is the actual case study. This is just for our understanding. We are going to use this data. This particular data set is a very small data set which has 5 customers: C1, C2, C3, C4. Usually Python starts with 0, C0, C1, C2, C3, C4. 5 customers are there. For these 5 customers, I have their credit score, and I have the expenses. These are the two features I have. What I want to do is I want to find the distance of every customer from every other customer. So right now, my shape of the data matrix is 5 cross 2. For calculating the distance of every customer from every other customer, what will be the shape of my distance matrix? What is the expected shape of the distance matrix? It will be C0, C1, C2, C3, C4 from here to everybody else, which is like C0, C1, C2, C3, C4. So the shape of the distance matrix will be If the shape of the data matrix is 5 cross 2, the shape of the distance matrix will be 5 cross 5. What is the general formula? If the shape of the distance data is n cross p, the shape of the distance will be n cross n. How many ever rows are there? That will decide. What I want you to do here is create this distance matrix. You will get some distance matrix like this in the output. You have like C0, C1, C2, C3, C4, C0, C1, C2, C3, C4. Create this distance matrix and answer two questions. Question number one, which are the two customers who are most similar? Which pair of customers? Which pair of customers are most similar? That is the first question. By looking at the output, we have to answer that. Question number two is which pair of customers are most dissimilar? Which pair of customers are most dissimilar? These are the two questions that we want to answer. First, let us get this output. Then we will proceed to the answering of these questions. Let's go to our Google Classroom. Google Classroom. Clustering, cluster analysis, code file, getting the link here, Colab link. I'm pasting the link in the chat window. Click on the link, import the packages that are required. Distance matrix, first get the data, get the distance matrix, analyze the distance matrix, you will get this as output. Try to answer question number 1 and question number 2 in the chat window. So go look at the output. I'm already getting the answers. Looks like for question number 1, most similar customers, C0, C1. May be correct, may be incorrect. You tell me your answer, not always correct. So tell me which are the most similar customers. The most dissimilar customers that I got are C1, C3. This is the pair that is most dissimilar. This is the pair that is similar. May be correct, may not be correct. Tell me your answer, okay? We'll discuss anyway the final answer. Once you have this output, let me know your answer. First, tell me about the most similar customers. Tell me the pair of customers whom do you think are the most similar. Try to look at that output. Find out who are the guys who are most similar. Most similar. Look at that, all of you. When do you say two customers are most similar in this group? Most similar means what? The distance between them should be, the distance should be between them should be minimum. What is the least number in this? Because I want to know the most similar, which means the least distance. What is the least number in this matrix here? The least number in this matrix is, how much is that? 1648, isn't it? It can be seen here as well as here. Since this is the distance between C1, C3, C3, C1, they'll be same, isn't it? Distance from here to here will be same as here to here. The distance between C1, C3 is 1648. So is it fair to conclude that C1 is the most similar customer to C3 in this group. These are the pair of customers who are very similar to each other compared to everyone else. These are the guys who are very similar to each other. Who are the pair of customers who are most dissimilar? Most dissimilar customers. Usually, you will say two customers are very dissimilar if the distance is maximum, very high. In this matrix, which is the number that is the highest number? Is it 20,998 or is there any higher number than that? There is one more number, 22,628. This is the highest, which is here and here. This is the distance between C0, C1 or C1, C0, both are same. The pair of customers who are very dissimilar to each other are C0, C1. So here we are only job is half done. What is it? We got to know who are similar customers, who are dissimilar. Later on, when we actually discuss the algorithm using this distance, we are going to club, or that algorithm is going to club the customers who are similar to each other, put them inside a group, and then put the customers who are dissimilar, who are having higher distance, put them into different groups. That algorithm will try to do that. But distance is the critical formula for calculation of the similarity or the dissimilarity between the given 2 points or the customers. If we have understood this distance calculation, we are now ready to discuss the clustering algorithm. So let us discuss this clustering algorithm. The clustering algorithm name is k-means clustering. K-means clustering is the algorithm name. What is this k-means clustering going to do? Very simple. K-means clustering will take the whole data as input. The input will be the whole data. The output is k-means clustering will tell these customers are falling in cluster 1. These customers belong to cluster 2. These customers will belong to cluster 4. These customers belong to cluster 3. Like that, for every customer, it will tell which cluster that guy belongs to. Basically, it does the grouping. K-means clustering algorithm. As an output, it gives the customer segments. That's it. That means customer 1, record 1 falls into cluster 3. Record 2 falls into cluster 0. Record 3 falls into cluster 3. Record 4 falls into cluster 2. Like that, cluster ID will be given as the output for every customer which cluster he falls in. K-means clustering is going to take the full data as the input and give us the clusters as the output. K here stands for the number of clusters. Okay. So K need to be given as input here. If you want to form 5 clusters, K-means clustering will take your whole data, divide this into 5 parts and give it to you. If you want to form 10 clusters, it will take the whole data, divide it into 10 parts and give it to you. K need to be given by the user. Usually in the initial phase itself, we will not get to know what is the optimal value of K. Nobody will get to know what is the optimal value of K, what is the optimal value of number of clusters I should form. So my suggestion would be try a number that is between 3 to 10, get the first set of output. Based on that, we may have to rebuild by adjusting the value of K. Because in one go, you will not be able to get the best model because we don't know the optimal value of K. So the suggested number is try K as some number between 3 to 10. If the number is too less, you will get to know by studying the output, then increase K, rebuild the model. If the number is too high, you will get to know. We are also going to discuss how to study the output. When you do the inference on the output, you will get to know I have built too many clusters. Then you may have to club few clusters, which means you reduce the value of K. But in the beginning, you will not get to know. This is something like max depth. In decision trees, is it possible for me to get the max depth in one shot? How did we do? How did we find the max depth? Do you remember? Take a smaller number, take a higher number, overfitting, underfitting, all that happen, and then you fine tune and find the best value. Exactly similar way here also. By studying the output, we have to decide what is the optimal K. In the beginning, my suggestion is for most of the practical problems, the number between 3 to 10 works perfectly for me. It should be working perfectly for you as well. Okay. Later on, we will anyway fine tune it. Okay. Now, let us suppose for this particular problem, I start with, let's say, k equal to 3. Take this data, make it into three groups. Three groups means three clusters. Then how does cluster analysis algorithm work? How does it take this data and make it into three clusters? What is the clustering algorithm? What is the theory behind it? What is the mathematical derivation of this? Let us see. For example, if you say 3 here on this data, what it will do is it will take 3 points, three customers randomly. Underline the word random there. Randomly 3 points are taken. They will be called as clusters. This is cluster 1, only 1 point is there. Cluster 2, 1 point is there. Cluster 3, only 1 point is there. So here the clusters are blue, red, green. These are the three clusters. Okay. Cluster 1, cluster 2, cluster 3. After that, take any other random point. It can be any other point. Take any other random point. Calculate the distance of this point from cluster 1, this point from cluster 2, this point from cluster 3. What I'll do is this particular algorithm can be little confusing. I will walk through this algorithm twice. In the first go, I'll try to just go through it once without taking any questions. In the second iteration, I will take the questions slide by slide. Okay. First, I'll just explain it the whole algorithm once. Okay. So take this point, calculate the distance of this point from every other cluster. Okay. And whichever cluster it is closer to, apparently this is close to the blue. Add this point to the blue cluster. Now in the blue cluster, in cluster 1, you have 2 points. Customer 1 and customer 2, both the points are there in cluster 1. After that, update the cluster center. What do you mean by updating the cluster center? So he is customer 1. What are his details? For example, we have the details of, let's say, feature 1 is income, feature 2 is number of loans. Okay. Customer 1 income is something like 35,000. Number of loans are 2, let us suppose. Customer 2 income is 35,000. Number of loans are, let's say, 0. No loans are there. Now, what do you mean by this cluster center? The cluster center is average of these two customers or all the values in that cluster across all the columns. So the average of two incomes is 35,000. Average of two numbers is 1. So this point that you see here, it is neither cluster or neither customer 1 nor customer 2. It's a different point. It is also known as centroid, or it is also known as cluster reference point. So if I want to calculate the distance of any point from this cluster, I don't want to calculate from here to here. I don't want to calculate from here to here. This is the cluster reference point, which is known as cluster center or centroid. This is the center here. That is what that center, that is how it is calculated. Then what do we do? Take any other random point. Take any other random point. Calculate the distance of this point from here to here. Here to red cluster, here to green cluster. Add it to the cluster which it is near to. After adding this point, update the center. How do you update the center? Calculate the average across C1, C2, C3. Next step is take any other point, calculate the distance from here to here, here to here, here to here. Whichever it is near to, add it to that cluster. Apparently this is near to blue. Add it to blue. Update the cluster center. Take the next point, calculate the distance from here to here, here to here, here to here. Apparently this point is closer to green. After adding this point to green, update the cluster center. Now please pay attention. Once the cluster center gets updated, once the cluster center gets updated for any new cluster, whichever points that we have added until now, whichever point we have assigned to a cluster, including the initial centers, whichever point we have assigned to a cluster, try to check whether they still belong to that particular cluster also. That means this point, does it still belong to blue? This point, is it still closer to blue? This point still close because the center has changed. Is it still closer to blue? No, it is closer to green. If there is a case where there is a particular point which is closer to a different cluster after cluster center updating, reassign that point to that new cluster where it is closer to. Why do we need to reassign? Once the cluster center got changed, this point seems to be closer to a green cluster. It has to be part of the green cluster. It cannot be part of the blue cluster. So the important point here is once a particular point is added to a cluster, once a point is added to a cluster, there is no guarantee that it will stay there forever. There may be a case once it gets closer to a different cluster, eventually it will be falling into that cluster. So this reassignment step is the correction step. Otherwise, we were randomly adding the points to the clusters. There has to be a place where we are doing the correction and keeping the right points near to the right cluster. This is that correction step. So we keep on repeating the step of assignment and reassignment. Assign it to the nearest cluster. If it happens that it falls later on near to a different cluster, add it to that. Eventually, maybe some points are part of some other cluster, but eventually they will be part of a cluster where they are close to the rest of the values. It will never happen that a particular point is close to green, but it has been part of the blue cluster. It will never happen. Maybe in the initial phases it may happen. Eventually this will be part of the green cluster because the distance will be calculated always, and if the distance is smaller, it will be added to that cluster. Repeat this process multiple times. Finally end, stop this algorithm once every point is part of a cluster. So here these are all the blue cluster, red cluster, and the green cluster. This is how cluster analysis algorithm works in the background. The critical step in that cluster analysis is that reassignment step. Let me play some animation to explain this slightly better. Imagine this is our data. I always knew that this will be forming a cluster. There is no doubt about it. I always knew that this will form a cluster. This may form a cluster. This may form a cluster. This will be one or two cluster. This will be a cluster. This will be a cluster here. These are all the clusters here. I know. But there is no guarantee that in the beginning there will be definitely a center here. In the beginning, this point will be center. In the beginning itself, there will be centers here. That I cannot guarantee. Maybe some of these points will be part of this cluster in the beginning, but eventually they will form a cluster. Maybe some of these points are part of this cluster, but eventually they will form a cluster. So let us see what happens in iteration by iteration. Look at this. Focus on the top one. Focus on the top cluster. Look at that. Eventually it ended up like a yellow, or let's call it as green. Eventually it ended up like a green cluster, light green. But not all points were green from the beginning. Some of these were closer to blue. Some of these were closer to purple in the intermediate iterations. In the intermediate iterations, focus on this cluster. Some of them were part of blue, some of them part of purple, because at some point these were closer to this cluster. When this center was here, these were closer to this cluster, but eventually they formed a cluster. Next time when I play the animation, you try to focus on this cluster. There was no center in the beginning. Sometimes it was part of this cluster, sometimes it was part of blue, but eventually they formed a cluster. Check that out once again. Focus on this cluster. Look at this. Most of the points are part of green, later on blue. Finally, they ended up like their own cluster called red. So there were 3 points here in the beginning. These are the 3 cluster centers. One of the center eventually moved here. Another center eventually moved here. Another center eventually moved here. So it doesn't matter, even the cluster centers are nearby. Finally, the points that are close by will always form a cluster. Think about it. Will it ever happen that there is a point here, but still it will be part of blue? Is it possible? Will the cluster analysis give us such kind of output? Is it possible in the algorithm? Will the algorithm allow it? There's a point here, but still it is part of blue. Will it happen? Which step will correct it? You calculate the distance from here to here. You calculate the distance from this center to this center. This is higher distance. This is lower distance. This must be part of this cluster only. Maybe in the intermediate phases, some of these points were part of blue, I agree. But eventually, when the center reached here, when this center was here, these points were closer to this blue. That's why they were blue. But when the center reached here, then most of the points are closer to this one. This one formed a cluster. That is how cluster analysis works in the background. The step that really does the real clustering is the reassignment step. This way, cluster analysis uses the distance and tries to give us the output by dividing the data into clusters. Let me go to that first slide once again. K means clustering, stands for K here, stands for number of clusters. In the beginning itself, we will not get to know what is the optimal number of clusters. It is true that no matter how small or how large data that you are using, it is impossible, no matter how much experience we have, it is impossible to come up with the optimal value of K and say that, you know what, this is the optimal number of clusters, use them, it will work. You cannot say that. You have to try a number, some value. Usually for general industry problems, 3 to 10 works perfectly, somewhere between 3 to 10. Study the output. Based on the output, if you feel that you have to increase the number of values of K, number of clusters, increase them. If you feel that reduce the number of clusters, reduce them. In this example, let us suppose if we say K equal to 3. How does cluster analysis work in the background? In the beginning, it will take 3 points randomly, and these 3 points can be anywhere. They can be these 3 points, or they can be these 3 points, anywhere. Randomly, 3 of the points will be taken. They'll be called as clusters. Cluster 1, cluster 2, cluster 3. After that, another point will be taken. From here, the distance from every other cluster will be calculated. If this particular point is closer to the blue cluster, it will be added to blue. The cluster center will be updated. How do you update the cluster center? It is simply average of all the points in that cluster across all the columns. It is also known as centroid or the reference point for that cluster. That means when we are calculating the distance of any other point from this cluster, we will be using that point as the center. Then take the next point, add it to the nearest cluster, update the center. Take the next point, add it to the nearest cluster, update the center. Take the next point, calculate the distances, add it to the nearest cluster, update the center. Now, once the cluster center gets updated, whichever points that we have added until now, to a cluster, since this cluster center got updated, all these points need to be rechecked, re-verified, whether they still belong to this blue cluster, whether this still belongs to red cluster or not. If at this step, if we find that some points are closer to green rather than blue, we will be adding this point to that green cluster, changing the cluster IDs. It is known as reassignment step. This is the correction step. Update the cluster center. Keep on adding the point. First add this point to the nearest cluster. If there's a correction required, do it later on. Add it to the nearest cluster. If there's a correction required, do it. As apparently maybe this is closer to red one now, but later on if there's a correction that is required, we'll do that correction. Eventually, if this one ends up in blue, it may end up in blue, but we cannot say that once a point is added, maybe this one is right now closer to red, but later on at some other step it may be closer to green. Once a point is added, there is no guarantee that till forever it will stay in that cluster itself. Like that, eventually the closer points that are close to each other, the customers who are close to each other, they will be inside one cluster. The customers who are far away from each other, they will be in two different clusters. So when we are working on cluster analysis, there is no guarantee that all the centers are equally spread everywhere. The cluster center will be initialized properly in one shot. No, they can get initialized anywhere. But eventually all of us will get the same answer because the distances will be same. So for all of us, this will be cluster 1, this will be cluster 2, this will be cluster 3, like that. So the answer will be same. The only thing would be the center starting points may be different because they are randomly assigned in the beginning. That is a theory of the clustering algorithm. Any questions on this? Anyway, we are going to do a case study. And when we get to a case study, there are some practical aspects that cannot be seen in this theory. We are going to discuss those nuances as well and some of the fine tuning techniques, etc. Usually, clustering is used in retail, mostly retail and marketing spaces across all the industries. But when it comes to retail, clustering is most prominently used because in retail, it's not just one product that you are selling. There are a hell lot of products that you can sell. So you want to see the customer as a full package. If it is a bigger product, something like loan or something, in a loan, you are going to give only one loan. So you will carefully look at each customer. If it is a car or if it is automobile, then you are going to sell one car to a customer or maximum two cars or three cars, that's only. Or if it is a home loan, you're going to give a one loan. Then you will study each customer from the point of view of your product. But in retail, you are going to sell him hundreds and hundreds of products. So here, we will not really get the target variable because we consider everybody is buying everything. So what we want to do is if we want to run a marketing campaign, we want to divide them into customer segments, study each segment, see what is the best possible strategy that can be applied on that segment to gain the maximum possible, return on investment. Okay. This is one of the example taken from a real data set, inspired from a real data set after a little bit of cleaning. Okay. So a supermarket wanted to send some 100 promotional coupons. Here in India, the promotional coupons that we get are not really worth because most of them are kind of small discount only. But in some other places, in US and all that, those promotional coupons that you get are really worthy, almost equal into money or something. So there is some budget that is required for the company, for the supermarket to spend. When they give this promotional coupon, definitely there will be some cost associated with it. Obviously, when you are spending some money, the client will require return on investment. We have to build a strategy that will use this budget carefully and then, you know, give us whatever we have to show since we have spent this much amount and this is the return that we got. So the idea here is we have shortlisted nearly 3,000 potential customers. These are the 3,000 potential customers. We have been tracking them. Okay. Now what we want to do is out of these 3,000 potential customers from a particular region or from a particular place, we want to float 100 coupons. We want to float 100 coupons. Now, we don't want to randomly select people and float these 100 coupons. That's not going to help us because these 100 coupons cost us some money. So we have to show some return on investment. So the strategy that retail industry, you know what they follow? This is what they do. So one of my friends, she works in Target. This is exactly what they do. Their team day in, day out. So what they'll do, they do some customer segmentation, select some particular set of customers and send them the coupons. Coupons is the only thing from past few years they are doing the same thing. Do you know Target company? Where is it? In for them, the analytics is done by Indians only. We are the ones who are giving them outsourcing. Have you ever heard of this company? Like somewhere in Hebal, there is one branch. Even in EGL also there is one company. Like it's totally red, red, red everywhere. It will be red. Free food and good company. So what is the idea here? Divide these 3,000 customers into some kind of segments. Divide these customers into segments. Choose that segment which is following these two criteria. Criteria number one, the segment that we are going to choose should follow this criteria. Criteria number one is the customers in this segment should have medium to high income. Medium to high income. The same segment, criteria number two is the customer should have medium to low recent spendings. That means medium to high income means customers have spending capacity. Medium to low recent spending means they are not spending with our company. That means they are buying the stuff from some other supermarket. We want to target that customer segment, which is medium to high income, medium to low recent spendings. Do you think if I want to find such segment, do you think out of 3,000 customers, exactly there will be a segment like this, which has exactly 100 customers, which is satisfying both the criteria perfectly? Will it ever happen like that? Will it be like that in general for practical scenarios? In general practical scenarios, it will not happen that exactly a segment which is there sitting there to be detected. It will not happen. We will try to do our best to get the best, you know, segment which is satisfying maybe both of them or maybe at least one of them. These criteria it should satisfy. So for solving this problem, we are going to use the cluster analysis first for doing the segmentation. Okay, let us see the code part of it. Let's go to the code file, all of you. You can do it along with me. Import the data set, supermarket data, customer ID, age, customer estimated income, recent spends, family size, average visits per month. This is the data that we have. We want to use all these features first for dividing the data into clusters. Okay, first let us use all these features for dividing the data into clusters. Okay, here is the code for dividing the data into clusters. From sklearn, import k-means function. K-means underscore model is my model name. K-means underscore model equal to k-means is the function. N clusters equal to 5. Can you tell me what does n clusters equal to 5 mean? Can you make a guess? What does n clusters equal to 5 mean? It means here we are forming the number of clusters are 5. In general, do we really know at this point of time whether 5 is going to work? Is a 5 a perfect number or not? Do we really know at this point of time? Generally, in the beginning itself, you will not get to know. What is the general suggested number when you have no idea? What is the number that you must try on practical problems? On a wide variety of problems, when people have tried, even the experts, they suggest that maybe try a number between 3 to 10. Okay, when you are in doubt, study the output, then do the adjustment. Okay, that's the method that we have to follow even in practical scenarios. Number of clusters equal to 5. Now, random state equal to 333. This is an optional parameter. When you are working on real projects, this is not required. But I gave this extra parameter for a particular reason. Here is the reason why we have to choose that random state only in this classroom. For example, this is the data in my system. In my system, when I said n clusters equal to 5, these 5 points are taken as initial cluster centers for me. In your system, these are the 5 points that are taken as initial cluster centers. For someone else's system, these are the 5 points they are taken as initial centers. For somebody else, these are the 5 points. Everybody will be, since this is randomly taking the cluster centers, everybody else would be getting everybody like different cluster centers in the beginning. Eventually, we'll get the same output because no matter where you start, the clusters will be same. But the only difference would be my cluster ID 0 will be someone else's cluster ID 3. That will be someone else's cluster ID 2. That will be someone else's cluster ID 4. That means if we are comparing our output, if I'm talking about cluster 0, ID 0, you have to look at your cluster 3. Somebody else has to look at his cluster 4. Someone else has to look at his cluster 1. So it will be very confusing. So how do you make sure that though you are generating random numbers, how do you make sure that you are generating the same random numbers? In general, any of the coding languages, if you want to generate the same random numbers, you can mention a particular parameter. What is that parameter name? I want to generate a random number between, let's say, 1 to 100. But I want you and I, if we want to, both of us want to generate the same random number, you can give something called seed. If you mention seed, you will get the same random number. So here in Python, that seed is mentioned using a parameter called random state. If we give random state, all of us give the same number. The number can be anything. Random state equal to 12, random state equal to 30, random state equal to 100, or here random state equal to some number 333. If all of us give the same random state value, then all of us, the starting point will be same. For all of us, the cluster centers randomly chosen but the same random points will be picked as the starting point. What is the advantage of it? The advantage is only in this discussion, all the cluster IDs will match. My cluster 0 will be your cluster 0, will be everybody's cluster 0. So that we can discuss, and later on we are going to do the fine tune and adjustment. For that it is necessary. But in real world, do you really need to match your cluster IDs with anyone else? No. So make a note here. This is optional parameter random state. This is required only when you want to generate the same cluster IDs in the beginning for everyone. Is this random state clear, everyone? It's an optional parameter only in this classroom we are using. Clear? All right. This is the model configuration. I'm preparing the data here. X equal to from the supermarket data. I'm taking every other column, but I'm dropping the column called customer ID. Customer ID is not customer feature. I should not compare customer IDs. I should not say that customer ID 1 is very different from customer ID 2000, who is very different from customer ID 500. No, customer ID should be kept aside. So we should not send that data for model building. We should use that data for identification of the customer only. So I'm dropping it, preparing the X data by dropping that. When you're dropping a column, you have to use access equal to 1. When you're dropping a row, you have to use access equal to 0. That is Python syntax. Finally, you will say model.fit, supply the data of X. Usually, whenever we say model.fit, we have a habit of giving model.fit X comma Y, isn't it? But is there any Y variable here? There is no Y variable. This is an unsupervised machine learning model. So give the X data. That is sufficient. Cluster analysis will do it. The moment you say model.fit, that whole clustering algorithm that we discussed, the whole theory will take place. That means calculate the distance of every point from every other point, and then randomly take 5 points, and then call them as clusters. Take the other point, calculate the distance, add it to the center, and then do the assignment, do the reassignment. The whole thing will happen. Everything will be stored in k-means result. This is the result of the clustering. The result is pretty straightforward. If you say k-means result dot predict, give the x value, what will you get in the output? First row, first customer, which cluster he falls in. Second customer, which cluster he falls in. Third customer, which cluster he falls in. We are storing all of them in something called labels. So first we'll execute this. That will give us the clusters. Get the labels. What are labels? For every customer, what is the cluster ID? Now I'm going back to supermarket data. I'm adding a new column at the end, which is nothing but cluster ID. Cluster ID is the new column where I'm adding the cluster ID number here. This is how the first 5 records look like. 4 of the 5 records fall into cluster 0 only. Instead, if I print a sample of 5 records or sample of 10 records, then I may see different cluster IDs. Cluster ID 4, cluster ID 0, cluster ID 2, like that. The numbers will be 0, 1, 2, 3, 4. That will be the cluster ID. Until here, the clustering will be done. Later on, we will be doing the output inference. What I want you to do is execute until here. Once you have the cluster ID attached to the original data set, give me a message. Then the output inference, which is very important, we are all going to do it together. So first, do it until here and send me a message. Once the cluster ID is created, send me a message. Kishore, you want this slide to be explained or do you want the code to be
No, no,
re-explained? Yeah.
not the code,
Yeah.
the slide that the scenario of this.
You mean to say what is the final cluster that we are looking for, is it?
Yeah, yeah, yeah.
Yeah. So what we want to do is we want to form these 3000 customers into some groups, some clusters. We want to choose that cluster which are having those customers in that cluster should have medium to high income. That means they should have the spending capacity, which means their income should be either medium or high overall when compared to others. Okay.
Okay.
As well as they should have medium to low spending. That means they have the spending capacity, but when I look at the recent spendings with our supermarket, those numbers are lesser comparatively. Okay. Such cluster is our target customers.
Okay. Okay.
By giving them the coupons, you're making sure that they have the spending capacity since they are spending with some other companies or they're spending with other supermarkets. Maybe there will be a highest ROI. That is the idea.
Okay. Okay.
Yeah, that's the plan. It may work, it may not work, but that's the plan right now. Yeah.
Okay.
Yeah, and there is no guarantee that since we have 100 coupons, exactly 100 customers will form one cluster like that. That is also there is no guarantee. Only by looking at the output, by inferring only, we will get to know whether we'll be able to get this or not. Okay, which
Okay.
is pending, which we are going to do now.
Okay. Thanks, Uncle.
All right. Now, the first thing that you should do is cluster count. Cluster count means the number of records in each cluster. You have 5 clusters. So you have 3000 records. If you are forming 5 clusters, how many records will be there in each cluster? How many records? Is it fair to assume that there will be 5 clusters? Each cluster will have exactly 600 records. Is it a fair assumption? In reality, will it happen like this? Our real data is such fairly distributed. Is it like that? No, it will not happen like that. It'll never happen. If you go to any outside world, if you look at income, it will not happen that people are certain range of income are exactly same. People who are earning from 1000 to 5000 will be same from 5000 to 10,000. It will not be like that. It is not such very uniformly distributed. You may know that out of 3000 records, nearly almost half of the records, 1500 or something, will be forming one cluster. Most often what happens is people are near to very most of the people are near to the average. People who are earning average income will be very large in number. That is why when you are forming clusters, there will be always one or two clusters. In academics, in academic examples, these kind of clusters are not shown. But when you actually jump into real life, you will always find a cluster which is covering almost half of the records. 1500 records or maybe 1700 in fact can be part of one cluster. No matter what you do, all those records will be part of one cluster only. Always you will find a cluster which is huge, definitely. Always you will find another cluster which is taking 1% or 2% of the data only. That means out of 3000 records, only 10 records are falling here, only 5 records are falling here, only 15 records are falling here. Always you will find a cluster that is very, very small in size, which means having very less number of records. Can you make a guess what this could be? There are some records, there are some customers who are far away from every other customer. What does this sound like? There are some customers who are far away from everybody else. They are not mixing with everyone else. These are kind of very special, very far away from everyone else. Usually that ends up like outliers. These are the outliers customers. What do you mean by outliers? Their values, their incomes, their expenses, or any other factor that you compare with everyone else, they are very, very far away from each other. So usually, definitely, you will have a cluster that is very large in size. Usually, you will have a cluster that is very small in size. That is a real data. But generally, in academics and textbooks and all that, we tend to get optimal cluster sizes, and every cluster will have same number of records, but that is not what you are going to see with some of the data sets that you are going to work on. Okay, so tell me, go to the cluster count part of the code snippet. Tell me cluster by cluster how many records are there. All of you execute the next code snippet, cluster counts part of it. Tell me cluster by cluster how many records are there. Cluster 0 has 1214 records. C0 1214 records. C1 has 45 records. C2 has 513 records. C3 is a very small cluster, 3 records only. C4 again has 1225 records. Is this what you got, all of you? C1 has 1214 records. What is the first note that you're going to make out of this? What is the first note that you will take by looking at this output? In this data, if you look at this, there is one cluster with only just 3 records. We can think that C3, cluster 3 is kind of outliers from every variable point of view. Until now, we have seen outliers from a univariate analysis point of view. But these are the outliers from all the dimensions, because for calculating distance and all that we used all the features, all the dimensions. There are 3 outliers. C3 is outlier. So keep it aside. We will talk about it later. And there are only 3 records. If you are thinking that there are only 3 records here, if I would have formed 4 clusters, these 3 will be mixed with 45, there will be 48 here, then I'll have decent size. It will not happen. It will not happen. Even if you're forming 4 clusters, maybe these 45, some of them will be mixed with 1214, some of them will be mixed with 1225. But there definitely in the 4 cluster scenario also, you will have 3 records that are, because these are not due to count. These are due to the nature of the data. That means these are really having very, very distinct values than others. Even if you're forming less number of clusters, they will be formed as an outlier for sure. They will always be far away from each other. So these are the 5 clusters and the number of records in each cluster. Then what I want you to do is look at the cluster means output. Cluster means output. Now we will use some kind of business logic. What is the business logic? Try to choose that cluster. Maybe 1 cluster or 2 cluster or 3 clusters may be satisfying this criteria. Try to choose that cluster which is satisfying our criterias. Medium to high income. First of all, keep this C3 aside, okay? Ignore C3 because it is having only 3 records. There is no point in discussing about it right now. So ignore C3. So focus on C0, C1, C2, C4. Focus on these 4 clusters. Out of these 4 clusters, tell me the cluster that is satisfying criteria 1, medium to high income, as well as criteria 2, medium to low recent spending. Which cluster do you think is our target? Try to analyze the output of cluster means and let me know which cluster do you think should be called as our target population. C0 or C1 or C2 or C3. Or C3 is ignored. C4. Which one out of these? Let me also look at the output. Cluster count. If we bar C3, ignore them. And we know why C3 is a different cluster, because it is when everyone is earning in thousands, these are the customers who are earning in lakhs. That's why they're very far away from each other, very far away from rest of the clusters. Now, medium to high income, medium to high income, medium to low recent spendings. Which cluster is satisfying that? This one is high income, high spending. So until here it is statistics. Whatever we have used is statistics. Now what we are doing is a little bit subjective. This is like picking and choosing based on our own need. So there is no certain rule that we have to take only that one. But let us see. This is the highest income. Second highest. I can call this as medium income. Ignoring this one. Highest income, medium income, and spending wise also low. If I go through this, I would rather say C2 is my target segment. This is my target. This is a target set. However, choosing this target set, there is no certain rule. This is subjective. If you have a better logic, then we can choose other one. Usually people don't choose target set. The most widely used application of cluster analysis will be study this cluster, apply a strategy. Study this cluster, apply a strategy. Study this cluster, see what strategy can be applied. That's what people do. But here we are solving a different problem. We want to choose a particular set and then try to target them. So here, this seems to be my target set. When I was giving this training in a retail company called Tesco, there they suggested me even a better method. You know what they told me? Since they are already in that business, they're already doing something like this. What they have suggested is if you look at C1, they are earning high, they're also spending a lot. So what they observe is, according to the customer psychology, people who spend a lot, like kind of impulsive buyers, if you give them the offer, though they are already spending a lot, almost highest, ignoring C3, they are the highest spenders. If you give them a coupon, there is a high chance that they will even spend. So people who are impulsive buyers, by giving coupons to them, there's a high chance that they will spend. There will be higher ROI in that segment. So for me, apart from C2, that logic also sounds good. C1 is also our target. C1 45 customers, C2 513 customers. Both of them together, it will be 558. This is my target set. So for me, from 3000 customers, I have came down to 558 customers whom we will be targeting. However, how to pick the target customer set, that logic is not driven by statistics. That logic is driven by your business case, and it is highly subjective. Okay. So whichever is satisfying, we will be choosing that particular cluster. Here we choose two clusters, 558 customers. But what is the twist here? Do we have the budget to give the coupons to all these 558 customers? What is the budget allocated? How many coupons have we got right now? We have only 100 coupons. Then how do you distribute these 100 coupons in these 558 customers? Any idea? So right now, my target set, let me take this target set, cluster ID 1, or here number should be 2, isn't it? Not 3. Cluster ID 1 or cluster ID 2, there are 558 customers. I have them now, but I have 100 coupons. Can you give me an idea? There are two ways of doing it. Anyway, I have done all the hard work of coming down from 3000 to 558. I can simply choose randomly 100 customers from here. That I can afford right now. That is one way. But if I want to do it mathematically, statistically, the perfect way, I don't want to put any question on this. What could be another method that you can follow? Like the way you came down from 3000 to 558. What will you be doing? Try to think about it. What can be the other possibility? You can actually further apply clustering on, complete the statement, apply further clustering, maybe 3-4 clusters you are going to form, apply clustering on these 558 records, maybe 4 or 3 or 4 clusters that you will form, then finally choose maybe 100 or 120 customers and then choose them. Though you have started with 5 clusters, though your K was 5 in the beginning, later we combined them and we ignored one of them. Finally, we used only 3 clusters. Within those 3 clusters, one of the clusters we made it into 4, overall 3 plus 4, 7. So eventually we ended up with 7 clusters if we are doing this further clustering. That is the reason why the initial value of K that you choose, it doesn't really matter. Because I know that at the end of this analysis, we are going to club few clusters. Let's say K equal to 10 is what we have started. It doesn't necessarily mean strictly we'll have 10 clusters. Maybe after doing the inference on the K equal to 10 clusters, maybe we club 3 clusters. That means you will eventually end up with 7 clusters only, because 3 clusters are formed as one, remaining 7 will be there, overall 8 clusters will be there. So it is possible that we may club few clusters after looking at the output. The initial value of K doesn't really strictly hold good after doing the analysis, after doing the inference. That is the reason why you can start with a number between 3 to 10, look at the output based on the business case, you have to find out the cluster. You have to maybe further cluster out, or you can take the target and then take the random value. That is all the theory of clustering, and this is how it is applied. However, all of you, please focus. Very important point coming up. In clustering, this is all the model building. As a good data scientist, tell me, we should not forget something. Tell me, we are all good data scientists. This is day 3, right? Right after model building, so clustering model building is done. But are we going to apply the strategy right away? Are we going to give it to the client? Whenever you submit anything, whenever you say, I have predicted this, whenever you give a prediction to the client, what will be the immediate question the client will ask you when you are submitting any predictions to the client in the general final presentations? This is what we are predicting. This is what we are predicting. These 100 customers are going to give us the best results. Whenever you do prediction, whenever you say this customer is going to buy, whenever you predict a model, or whenever you say this model is going to predict, the client is going to ask you, okay, what is the accuracy of your model? How good are your predictions, isn't it? In different ways they'll ask you, but eventually they want to know how good this model is going to perform. After building the clustering, we have to validate the model, isn't it? You have to look at the y actual values. You have to compare them with y predicted values. Maybe if they are continuous, you can use R square. If the y actual values are continuous, y predicted values are continuous, you can use R square for model validation. If y actually is zeros and ones, if y predicted is zeros and ones, you can use confusion matrix and accuracy. But how do you validate clustering? Do you have y actual values in cluster analysis? Do you have the y value? Do you have the y value in cluster analysis? Clustering is an unsupervised machine learning model. Is there a possibility of y actual value? No. Do you have the y predicted values? If you have no y actual values, how can you get y predicted values? No. If you do not have y actual, if you do not have y predicted, then unsupervised learning models cannot be validated. Cannot be validated. That means I'm going to give you the results. I'll give you my cluster results. I'll tell you that these are the customers you should target. But if you ask me in return one question, okay, you gave me these results. What is the accuracy of your results? If you ask me, can I give you a solid answer? If I build a decision tree, if I give you the predicted results, if you ask me what is accuracy, can I give a solid answer there? If you ask me what is accuracy, I can tell yes, my accuracy is 80%. If somebody asks me, how can you be so sure? What will we tell him? We have tested, we have actually validated it on the trained data as well as not only on one data set. If somebody asks, what is the proof that it will work in future? What are we going to tell him? It is not only validated on the trained data, we also cross-validated it on the test data. There also it shows 80% accuracy. I'm pretty sure that it will work everywhere. So decision trees, are we very confident about our results? Whatever is accuracy, we are very confident. But can you be very confident here without validation in clustering? If I'm presenting some results to a client, if he asks me what is the accuracy, is there any accuracy measure? By nature, unsupervised learning models cannot be validated. You need to be extremely careful while you are working with unsupervised learning models. I myself have failed in the beginning. I thought a decision tree and cluster analysis are almost same. This is also segmentation, this is also segmentation. What's the big deal? But only when I used cluster analysis in the final presentation when I failed, then I realized cluster analysis has a very big loophole. What is the biggest issue? Every time when you present anything which is prediction, always the client is going to ask you how accurate your predictions are. At that time, no matter what statistical measure, what academic measure that you bring in, if it by true nature, cluster analysis do not have the target variable, so they cannot be validated. That's a very huge statement. You may search the whole websites. There is no way you can solidly validate a unsupervised learning model because there is no why at all. That is why clustering, you must use it in the scenarios. Underline this point. You must use clustering in the scenarios where there is very less loss of misclassification. By mistake, if you do any misclassification or wrong prediction, the loss associated with that wrong prediction, if it is negligible or if it is very less, then only you use cluster analysis. If there is a very high cost associated with misclassification, you must use supervised learning model only. You cannot apply unsupervised learning model. Let me give you two examples. I want to build a strategy to do the email marketing. Email marketing. I want to send emails and I expect the customers to respond. Maybe insurance product or something I'm selling. I'm trying to send an email, then the customer responds. So I want to predict whether this customer will respond or not. I want to target a set of customers. After finding out these are the customers who will respond, I'll send an email. That is one scenario. The other scenario is I want to build a model that will predict who are the bad customers before giving a loan. If a customer is good customer, I'll give a loan. If a customer is bad customer, then I will reject his loan offer. Now let us think. If you do one mistake here, one mistake, or let's say 100 mistakes. By mistake, you have sent 100 wrong emails, which means these 100 customers are not going to respond. They are non-responders. But you still sent an email because your model told you that send an email. These are the non-responders. These are the errors. The model has made 100 errors, which means these are all non-responders, but the model still sent them a mail. What is the loss here that you will face? You have sent 100 emails to wrong guys. They are not going to respond back to you. What is the error here? What is the cost here? Cost associated with this? Is there any cost of sending 100 emails to customers who are not going to respond? No loss or negligible loss. Maybe I'm employing a person, that person is sending those mails. So there is some little bit of cost, negligible cost. But by mistake, if you are giving 100 bad loans, let's say each loan is around 40 lakhs house loan or 10 lakhs personal loan, 100 bad loans you gave. These 100 customers are bad guys. They are not going to pay you back. Each customer you gave 10 lakhs. So what is the cost of your 100 mistakes here? Each loan is 10 lakhs. 100 mistakes will be overall roughly how much? 10 crores. Tell me, where do you need to use cluster analysis? Where you must not use cluster analysis? Where can you use cluster analysis? Where you should not use cluster analysis? Because you are going to take these decisions in future. You must be aware of where you should not use. Obviously, in the email marketing, where there is very negligible or almost no loss, here you can use clustering. Okay, here you can use clustering. Here you must not use clustering. You must know where you should not apply clustering. Otherwise, you will fall into that trap. Only after doing the full project, you will realize that this project need to be scrapped because the client is not satisfied with the results because they are not getting the answer that they are looking for. Will you be able to take this decision in future when a problem statement is given to you? You should apply clustering only as a last resort. Otherwise, always look for supervised learning models. In the industry of banking, finance, insurance, services, clustering is not preferred. Only in the retail and the marketing space, email marketing, SMS marketing, only in the retail space, huge number of customers are there. There only clustering is preferred. Otherwise, you want to have a solid accuracy measured there. You don't want to use clustering. Clustering is not a very famous technique that is used in banking and several other places. Clustering is famous only in retail space or branding or marketing space, advertisement space, in those spaces. Yeah,
Venkat, one small
yeah,
question. If
yeah,
we don't know the why
yeah,
in the second case,
yeah.
so
You have
what?
to buy the data.
Okay.
wait for the data to be generated by hook or crook. That is the reason why these companies, these banks, pay hell lot of money to the bureaus who are collecting the data. That is why there is a perfect system
Okay.
related to this financial and banking, isn't it? There will be some bureaus. In US, there are three bureaus. They gather. Everybody has social security number. So everybody's financial history. In fact, cash is very less in transaction there. Most of the places it will be cards. And for even for student, you have to have a credit history generated. So you will get student cards. You should have 3 years credit history. Then only all the other things will happen to you. So we buy the data from bureaus for every customer. If the data is available in-house, well and good. But most of the times we buy it from bureaus or say maybe some market research companies. We may have to pay some money and get them. Since the data is not available, we should not apply clustering there. We have to, there the requirement would be if the data is not available, get the data, buy the data, somehow get the target and apply supervised on it. Good question. Any other connected questions? In this whole discussion, the important point is when not to use cluster analysis. Have I made it clear, all of you? When not to use cluster analysis? When not to use, when the cost of misclassification is very high, in those places, do not suggest cluster analysis. Okay, don't treat decision tree and cluster analysis the same way. Decision tree is a much more deterministic. Decision tree is much more decisive algorithm compared to cluster analysis. Well, that concludes our discussion on cluster analysis. Any questions on this? All right. If there are no questions, we will take a break now. After the break, we will move to the next topic. Let us meet at 11:35 a.m. and then restart this discussion. Okay? I'll see you on the other side. Welcome back, everyone. Once you're back at your desk, send me a message. While others are joining in, if anyone has any question, you can go ahead and ask me now. Okay. Now we are going to discuss a different class of algorithms. As I told you, whenever we are discussing a new algorithm, there is a reason why that new algorithm has been introduced. If there are already several algorithms like regression is there, logistic regression is there, decision tree is there, and why there is a need of cluster analysis, because cluster analysis is a different style. It solves different type of problem. Similarly, if there are already these algorithms, why there is random forest? There must be something that random forest can do, which the other algorithms that we have discussed until now may not be able to do. Let us understand what are ensemble models. One of the ensemble modeling technique is random forest. What is this random forest? Let us see. Imagine you want to order a mobile phone. You want to buy a smartphone. Amazon Great Indian Festival is going on. Flipkart Big Billion Days are going on. It's the Diwali time, and we will try to take the advantage of this and try to order a best mobile phone. And we have some specifications. This mobile phone should have this much RAM. The camera quality should be this. The screen size should be this. The price should be this. The battery specifications are this. Like this, I have some specifications. Imagine there are four phones A, B, C, D. All of them have same RAM, same camera, same screen, same price, same battery. All the four phones are satisfying all our criteria. Obviously, we will not be ordering all the four phones because we have only budget for one phone. How do you order here in general? Don't think from statistics or any other strategy point of view. In general, how do we order if we have four phones which are satisfying all our criteria? Same price, same RAM, same camera, same battery backup. You know what we tend to do? Knowingly, unknowingly, most of us we follow this technique. We look at all the ratings and reviews. If a particular phone has highest rating, which phone has the highest rating and the best reviews? Apparently, if C is that phone out of ABCD, we tend to go for this phone, which is C, isn't it? Generally, if you go that way, the phone that you get will be most often it will be the best because you have looked at the ratings and reviews. A lot of people are suggesting that this phone is good, then generally tend to end up like a good phone. This is the process lot of people follow, and it works for most of the cases. In fact, in psychology, it has been proved that this technique works. There's a name for it. This technique is known as the wisdom of crowds. The concept of wisdom of crowds tells us that one should not expend energy in trying to identify an expert within a group. Don't try to identify an expert. Don't go to a mobile phone engineer. Don't ask him what is the best phone. No need to do that. Instead, you rely on group's collective wisdom. Talk to people who have used this mobile phone. Talk to 10,000 customers or talk to 5,000 customers who have already used this mobile phone. If most of the people are saying the phone is not good, then definitely this phone will not be good. If most of the people are saying that, suggesting that yes, this phone is good, we liked it, then go ahead and buy it. You will end up with a good product for sure. That is what the wisdom of crowds approach is. If you convert that wisdom, and this usually works, it has been proven on several platforms and several places. In fact, there is a interesting YouTube video as well. Somebody takes a jar, okay, transparent jar. In that he puts a lot of jelly beans, okay, or you can think them as marbles, okay, in this jar. And he goes to New York street. He asks everybody in the street how many number of marbles are there in this jar. Everybody gives a prediction, okay. What he does is he takes the average of like from morning to evening. He asks everyone, he shows these jars to everybody. Everybody gives a prediction. Some people say there are 200 marbles. Some people will say there are 250. Some people will say there are 150. There people will say there are 170. Interestingly, at the end of the day, he takes the average of all those values and he gets somewhat like 210. Apparently, exactly 210 marbles will be there in this one. That means if you take the average of the crowd, kind of well-informed crowd, most often you will end up with a good prediction. So if we convert into model building, the wisdom of crowd approach will be converted like this. The problem statement is we want to find out what is the estimated monthly expense of a family in our city. Let us suppose this is what we want to predict. What is the estimated monthly expenses of a family in our city? In scenario 1, we gave this problem statement to an eminent professor. He builds one model. He gives us a single prediction. He predicts that $6,500 is the estimated monthly expense of a family. In scenario 2, we gave this to 100 assistant professors. Each professor builds their own model. Professor 1 says 7,500. Somebody else says 6,500. Someone says 6,000. Someone says 8,000. Someone says 7,800. Someone says 7,300. Like that, 100 models gave 100 predictions. We collated all those predictions. How do we collate? We took the average of all those predictions. And we got 7,200 as the final average predicted value. Final average is 7,200. If I give you a chance to pick only one out of these two numbers, what would be that? Are you going to go with Professor 1 result, or are you going to go with the average of 100 models? What do you think has a higher chance to be near to the actual value? In general terminology, most often, there's a high chance for this number to be near to the actual value. Instead of building one model, if you build hundreds of models and then collate their results, this process is known as ensemble learning. The exact pronunciation is ensemble. People tend to call it as ensemble learning. Ensemble learning. What is ensemble learning? Until now, the process is you have a data set, you build a model on it. It can be any model. You have certain accuracy. When the new data comes, apply the model, you get the prediction. That's it, you live with it. But here in ensemble learning, you take the data, you build model 1, model 2, model 3, model 4, and so on. Multiple models, model 100, hundreds of models. Each model 90% accuracy, 89, 88, 89, 86, 85, 90, 91, like that. Hundreds of models, each one of them have their own accuracy. When a new data point comes, this is one data point. For one data point, you will get several predictions. Model 1 is predicting as -1. Model 2 is -1. Model 3 is +1. Model 4 is -1. But for one data point, I cannot give 100 predictions. I cannot give 4 predictions. I have to give only single prediction for one data point. Tell me what will be that single predicted value, this data point, the predicted class is -1 or +1. Since most of the classes are predicting it to be -1, there's a high chance for that to be -1. That's why we predict it as -1. If it is regression problem, we would have averaged out. If it is classification problem like this, we take the class that is appearing most number of times. Most of the models are predicting it to be -1. We will take it as -1. So what are ensemble models? You take the data, build M1, M2, M3, M4, MK. K is a large number usually. Build K models, collate their output. If it is regression, collate them by averaging out. If it is classification, collate them by taking the class that is predicted by most of the models. Give that as the final output. That is the overall philosophy of ensemble models. But there is a particular procedure that we have to follow to build these ensemble models. These are not like randomly building the models. That particular procedure name is bagging. Bagging is an ensembling technique. Bagging is what we are going to do. Bagging stands for bootstrap sampling, aggregation of learners. Bagging has two parts. Bootstrap sampling is part one. Different type of sampling. We'll see what is it. Aggregation of learners. That means aggregating all the machine learning models. First, let us understand what is bootstrap sampling. Then we will discuss about bagging. Let us suppose you have a data set. Imagine I have a data set. The data set size, the number of records in the data set in this discussion, let's say 10 records are there. Record number 1, 2, 3, 4, 5, 6. 10 records are there in the data set. 7, 8, 9, and 10 records. Usually when you take a sample, suppose that if sample size is also 10, what will be this sample then? If sample size is also 10, number of records in the data is also 10, the sample will be nothing but the full data. Yes or no? If I take a sample of size 10, if the data is also of size 10, the sample will be full data. But if you talk about bootstrap sample, this is different. If you talk about bootstrap sample, for a bootstrap sample, the sample size will be 10 only. However, in the sampling, how do we draw? First, we draw one sample between 1 to 10. We draw one sample record. Okay. Between 1 to 10, draw one sample record. Draw one sample record between 1 to 10. One sample record between 1 to 10. Like that, repeat this process 10 times. Every time when you are coming here, 1 to 10, 1 to 10, 1 to 10. Repeat this 10 times. So this is called a bootstrap sample or a bag. This is bag 1 with 10 records. Bag 2 with 10 records. Bag 3, bootstrap sample 3. Bootstrap sample 4, bag 4. Inside a bootstrap sample, there can be some records that are repeated multiple times. Possible or not? Inside a bootstrap sample, there can be some records that are repeated multiple times. Inside a bootstrap sample, there can be certain records that can be ignored. 10 has been repeated multiple times, but 4 has been ignored here. 7 has been repeated multiple times, 7 has been ignored here. Inside a bootstrap sample, there can be few records that are repeated. Inside a bootstrap sample, there can be few records that are ignored. That is the specialty of bootstrap sample. You can think bootstrap sample as a sample with repetition, a sample with duplication. This is called bag 1, bag 2, bag 3, bag 4. The size of the bootstrap sample is the same as the size of the data. That means inside a bag, the number of records are same as the number of records in the data that you have. Got it? That is the bootstrap sampling technique. Now let us understand the overall bagging algorithm. Very easy. Here is the bagging algorithm. Imagine that you have a data set whose size is n rows are there. and t columns are there. For example, you can imagine n rows as, let's say, 20,000 rows for the sake of discussion. T column, something like 30 columns. Make k bootstrap samples or k bags, bag 1, bag 2, bag 3, and so on, bag k. Usually k is in 100, 100, 150, 200, like that. 200 bags, 300 bags. In each bag, what will be the size of this bag? How many records are there in bag 1? In bag 1, how many records you will find? In each bag, there will be n records, n records, n records, n records, n records, isn't it? The size of each bag is same as the size of the data. Does that mean this bag is a carbon copy of the data? Is it just a copy of the data? Is that the case? Will it happen that it will simply data set repeated here, same data will be repeated? Think about it. There will be few records that are repeated, there will be few records that are ignored here. There will be certain other few records that are repeated, there will be other records that are ignored. It will be very, very rare that two bags will have the same info. That's very, very rare. Even if they have the same info, maybe out of 100 bags, only 2 bags are matching. That means we can even consider the overall as 99 bags, but that itself is very, very rare. Same records repeating, same records ignored. Impossible. Even here, within 10 records itself, it is impossible, isn't it? Check. None of these 2 bags will be equal, no matter how many times you see. All of them. Check. Here. Definitely the things that are repeated here will be ignored here. The things that are repeated here will be ignored here, like that. Whatever is repeated in one place. 3 was never picked here, but 3 has been picked twice here, like that. Okay. On each of the bag, you build a model. Model. And the model building technique should be same. Let's say if you are building a linear regression here. This should be linear regression. This should be linear regression. This also, everything is linear regression. Or if you choose the model building technique to be logistic regression, this is logistic regression. This is logistic regression. This is also logistic regression. Everything, every model is logistic. Or decision trees, same decision tree, like that. Okay. Model building technique should be same. Tell me one thing, if the model building technique is same, is there any difference from model 1 to model 2, or they're just carbon copies of each other? What is changing from model 1 to model 2? Can you highlight? What is the difference between model 1 to 2? What is the difference between model 2 to 3, 3 to 4? Is there any difference, or they are simply carbon copies? What is changing between the model? If you observe carefully, the data is different. Focusing on certain part, ignoring another part. Focusing on certain part, ignoring another part. Focusing on certain part, ignoring other part. Focusing on certain part, ignoring other part. Data is changing. That is the bagging algorithm. Okay. Finally, every model will give a prediction. Let's say if you are building 100 models, 100 decision trees if you are building. Out of them, 80 decision trees are predicted the class to be +1. 20 have predicted the class to be -1. This is for one data point, you will get 100 predictions. One data point only you will send as input. 100 models will give you 100 predictions for a single data point. And then you will say that after collation, you will say that 80 models are predicting this single data point to be +1. There's a high chance for this point to be +1. Compared to a single model, something like regression or logistic regression or decision tree, compared to the single models, the ensemble models or a bagged model like this tend to give us 2% to 3% lift on the accuracy. For example, if decision tree itself gave us 90% accuracy, on the same data set without adding any new column, we can lift the accuracy to almost 92% or 93% if we are using bagging. It's almost impossible for any other technique to push it from here, isn't it? 90. Sometimes we are very much desperate for accuracy. In that case, these bagged models will help us to give slightly better accuracy than the single standalone models. This is the bagging algorithm. However, this bagging need not be done manually. There will be a package which takes care of all of this. We just need to mention some parameters, how many models need to be built, how many bags need to be drawn and all that. Otherwise, everything else is already part of a function. In fact, in real world, if you go to the real world, even bagging algorithm is not used widely. A special case of bagging is used. A special case of bagging is known as random forest. Random forest is a special case of bagging. Random forest is a bagging algorithm, but within bagging, instead of using any other algorithm, if you are specifically using only decision trees everywhere, model 1 is a decision tree, model 2 is a decision tree, model 3 is a decision tree, model K is a decision tree, then that is random forest. Usually random forest is the algorithm that is used. So let us see the random forest algorithm. Let us suppose you have a data set which has n rows. Let n be 20,000. T columns. Let T be 30 column. Make K bags, K bootstrap samples. Size of each bag would be n rows, n rows, n rows, n rows, n rows. And usually K, is it a smaller number or a larger number? Usually the number of bags that you should consider in ensembling. Generally, a suggested number is a slightly higher number in the range of hundreds, 150s, 200s, 300s, like that. On each of the bag, build a decision tree, decision tree, decision tree, decision tree, decision tree. Finally, how do you collate? Take all the predictions from all the decision trees when a data point comes, collate all the results, look at how many decision trees are voting for +1, how many decision trees are predicting it as -1. Whichever class is dominating, give that as a prediction. That is the random forest algorithm. So with this theory, what random forest tells us is, if you are building a random forest model, it always gives better accuracy than single decision tree. Nearly, it gives 2% to 3% lift than the decision tree. That's what the random forest algorithm claims compared to a single decision tree on the same data set. Sometimes that 2% to 3% lift has a huge dollar value. That's why we give it a lot of respect. That is a random forest theory. In theory, it is supposed to give 2% to 3% lift. Then there were some shocking facts that came into the picture when people started implementing random forest on the real data sets. When people started implementing random forest on the real data sets, these random forests started giving lesser accuracy than decision trees. What? A single decision tree, if I build, I'm getting a better accuracy than building 100 decision trees. People got totally shocked. What the hell is happening? That's what they thought. Then a lot of research scientists did some research on this and they found what is the reason for it. Here is the reason. The reason is, though there are some records that are repeated here, though there are some records that are ignored, in terms of the whole patterns, in terms of the whole info, this bag contains the complete information about the data. Almost all the patterns. Yes, few records are ignored, but in terms of patterns, it contains all the info. This bag contains almost complete info about the data, complete info. Information is present almost to complete extent in all the bags, which means when you are building this decision tree, almost the same decision tree result is coming here. That means if you are building this decision tree, if there are 10 rules, 9 rules are matching. Almost this tree is same as this tree. Almost this is same as this one. Almost this is same as this one. Almost all these 100 decision trees having the same rules. That means all of them are identical trees. It is almost like building one model, collating it 100 times. Is it really going to help us if we are building one model, simply collating it 100 times? It's not going to help us. Even in the first example, one professor versus 100 assistant professors. Imagine all these 100 assistant professors. If they are sitting inside a room and they are discussing among themselves, all of them together they built one model, submitted it 100 times. Building one model, submitting it 100 times, is it going to do a better job than a single professor model? Earlier we assumed that these are 100 models They gave 100 predictions. The average was going to work. That's why you picked these 100 assistant professors model. However, now it seems that one model only they have built, then it is not going to beat the professor model. So these have to be independent. The models have to be somewhat independent. They have to learn different patterns independently. They cannot be doing the same job everywhere. So to bring the independence, there has been slight adjustment that has been done to random forest. Then it started working perfectly once again. Random forest with some slight adjustment started giving better accuracy than decision tree. What is the adjustment? When you are building this decision tree, do not use all the T columns. Use only P number of columns. If you have 30 columns here, use 5 columns here. When you are building this decision tree, randomly choose 5 columns again, build the decision tree. Randomly choose 5 columns for splitting, build the decision tree. Randomly choose 5 columns for splitting, build the decision tree. Like that, randomly choose only P columns for building the decision tree where P is much less than T. Not just less than T, much less than T. So you're using only P columns, P columns, P columns everywhere while you are building the decision tree. That will make sure that this tree is learning something independently of this tree is learning something independently. Every tree is learning something very independently. It's almost like divide and rule. This tree focus on a particular portion of the data with a particular variable list of variables, particular portion of the data highlighted, particular list of variables. That is the algorithm for random forest. The question is number P same for all trees? Yes. Here if you are using 5, so the number P is not mentioned for one tree, we don't mention one number. For all the 100 trees, it is same. In terms of the count, this is 5 here, 5 here, 5 here, 5 here. If it is 5, if it is 6, it's 6 here, 6 here, 6 here, 6 here, everywhere it is 6. For all the trees, we are going to use the same count. However, random forest, we need to be little careful. I'll tell you what are the mistakes that data scientists are prone to do when they are building random forest models and how to avoid them. Here, the number of bags, the number of bootstrap samples or the number of trees, that is in our hand. K, the number of trees, isn't it? Number of trees that we are going to build. Okay. That is in our hand. Now, when we are choosing K, if we choose K wrongly, then our random forest would be going wrong. So what is the mistake that people do? If I choose K equal to 3 only, or if I choose K equal to 4, I'll be forming 4 bags. What will be the issue in that case? Think about it. If I choose K equal to 4, or if I choose K equal to a smaller number, if I choose K as a small number, something like 4 or 5 or 6, what will happen? Let's say if K equal to 4, let us think about that scenario. In this case, K equal to 4. So we will be choosing 5, 5, 5, 5. Are we even using overall 30 columns? Are we given a chance to use even 30 columns? You have 30 columns. Are we really using all those 30 columns? We are not even using all those 30 columns. So obviously we will be losing a lot of information. This will lead to underfitting. That's why the number K is in your hand, the number of trees. Usually what should be this number? This should be as large as possible. It's okay if you have a larger number. There is definitely no harm. As large as possible. Usually the suggested range is 50, 100, 200, 300, like that you have to use. Don't choose K number to be a smaller number. So K, the number of trees, is in your hand. You have to fine tune it. You have to give this number, and this has to be as large as possible. When you are working with your model, don't choose it to be a smaller number. Choose it to be 50, 100, 200, 300, 400, like that. That's the first point. We need to avoid mistake there. Number two, the number of features. The number of features. P is also in our hand. We have to set it up. Sometimes people with good intention only, but tend to get it wrong. Let us suppose I have 30 columns here. I choose P equal to 29. I want to build the best decision tree here. I chose 29. I chose 29. I chose 29. Everywhere I'm choosing 29 columns. Almost out of 30, I'm choosing 29 columns. Can you tell me what is the risk if I choose P to be very high number? If I choose P to be very high number, what could be the risk? If I choose P to be very high number, think about it. Out of 30, if I'm choosing 29 columns, out of 30, if I'm choosing 29 columns, 29, everywhere I'm choosing 29, 29, 29. What is the first issue? Why there is a need for P to be introduced here? Why there is a need for P to be introduced here? The need was that this decision tree was almost same as this tree, this tree. We want to make the trees independently learn something. That's why we got in P. But now are we fulfilling whatever we have got this P for? If you're choosing 29 columns here, 29 out of 30, almost this tree will be almost same, almost same, almost same. Model will not give you right result. That is why P, the number of columns P that you're choosing here must be much, much less than T. T is overall number of columns, overall data column. General benchmark that you can take is P can be chosen as square root of T plus or minus 2. This is not a rule. Based on my experience, I can share this kind of small formula that will help you. What is the optimal value of P? Around this, you can search, then you will get the right option. Let's say in this case, if your T is 30, what is the optimal number that you can choose? Maybe something like 4 or 5 or 6 or 7, something where 4 to 7. In this example, not always 4 to 7 will work. In this example, since T is 30, somewhere square root of 30 plus or minus 2. Okay. Somewhere like 4 to 7 or 5, 6, 7, 8, somewhere here. Usually the optimal values, yesterday also we have seen, right? Whenever you are searching for optimal values, are they exactly a single point values or the range of values in general? When you are finding the hyperparameter optimal values, what you'll observe is the hyperparameter optimal values are a range of values, which means if you are near to this, if 5 is optimal value, usually 4, 5, 6 or 7, they tend to give you the same result. So the number of trees, K, that should be a very large number. There is no upper limit for that, but lower limit is there. If it is small, then your tree will not be good. Your random forest will be a underfitted model. The number of features P, it has to be a smaller number. A general rule of thumb, a trick can be used. Square root of T plus or minus 2. Somewhere there you can search for the optimal value. It must be much, much less than T. There will be one more parameter called max depth, but that need not be fine-tuned with the rigor that we use. Like it is not as serious as these two parameters. These are the two parameters in random forest. Given that you have fine-tuned the random forest by giving these two parameters correctly, which we are going to see, we will take a problem and see whether we can fine-tune it or not. Usually fine-tuning is not a very difficult task. We will be able to do it pretty smoothly. Only thing is that we should know these tips and tricks, like what should be the value of K that I should try. Okay. Like if we are not aware of it, if you are trying 4 trees, after that you go to 5, after that you go to 6, after that you go to 7, it will take a lot of time. But if you already know that K has to be a very large number, you'll first try 50. If that doesn't work, you'll directly jump on to 100 or maybe 75, something like that. And the number of features P, if you have 30 columns, if you're starting with 28, 26, 27, that is going to take a lot of time. But if you take square root of T around that, if you search, then you will have the optimal values and your random forest will definitely give you better accuracy than decision tree, given that these two hyperparameters are fine-tuned accurately. That is the whole theory of random forest. We will anyway see a case study. Before going into the case study, are there any questions on this? Here is a video that I got from YouTube. This is a demonstration by Volvo. I think in last month I have also seen another advertisement by Volvo. They are introducing this feature in the cars as well. Apparently, the truck driver is not applying the brakes. There are some sensors, distance sensors, and all types of sensors are attached to the truck. The truck is actually detecting whether there is going to be any collision or not. Automatically, when it nears that collision, automatically there is a system that will raise the alert. Automatically, the brakes will be applied. That's what is happening. So somewhere some alert system will blink as soon as we approach this car. Some alert system will start blinking here. See this one? Then automatically it's a close shave, but automatically this will apply or reduce the speed or something. That's a demonstration by Volvo. Luckily, we have a similar data set shared by Ford. Their data set is slightly different. Ford, in around 4 million vehicles, around 4 million cars, most of them were cabs, I guess, they have attached some sensors. What are these sensors? Small devices. All of you might be aware of parking sensors, isn't it? Behind the car, you will have parking sensors. If it is a high-end car, even in the front side also, you will have sensors. Okay. So what Ford has done, they have attached all these sensors. They put some chips so that from these sensors, the data can be gathered and that data will be stored in those chips. Okay. So they have arranged a sensor one, some 7 sensors get the information on vehicle related data, vehicular data. What is it? What is the speed of the vehicle? One sensor will tell that. You don't need the sensor anyway, speedometer information it may be taking. Which gear you are in, what is the temperature of the engine, all those things, what is the wheel alignment, etc. etc. will be informed by 7 sensors. There are some 7 or 8 sensors that are gathering weather related data. Is it hot? Is it snowy? Is it raining? Based on that, what could be the friction, etc., etc. Some 7 or 8 sensors are getting the weather related data. There are some 7 or 8 sensors that are getting physiological data of the driver. Which angle he is looking at? Is he looking at straight or is there an angle that he's staring somewhere else? How many times this driver is blinking? Is he sitting in an upright position or a relaxed position? All those things are gathered by some. These sensors are small, very smart devices. They will pick up all this information very easily. Like this, they have gathered, they have kept 22 sensors in 4 million vehicles, 40 lakh vehicles, and sold all of them. Okay, they sold all of these vehicles and they waited for 1 year. Look at the journey to collect the data. They have waited for 1 year. In this 1 year, these 4 million vehicles are kind of special vehicles, so they have some tags attached to this. In this 1 year, some of these 4 million vehicles, it's very obvious, they have met with fatal accidents. As soon as one of these cars come to the garage, they have a special device that they will, it looks like a pen drive. They'll put that pen drive kind of thing, then it will get all the data. So let's say one car came to the garage, there was a fatal accident to that car, that's why it came to the garage. From the pen drive, they will get all the S1, S2, sensor 3, sensor 4, sensor 22, all these 22 sensors information just before the accident. What is the sensor recordings? What was the speed? What was the temperature like? What was the position of the driver? All those things they were gathering. Car number 2, just before the accident, what is the sensor details? Just before the accident, like that, several cars that have come to the garage, they have gathered all the details of the sensors just before the accident, and then they have tagged this as fatal accident. Fatal is the target variable. They have tagged it as 11111. So to get the target variable 1 or 0, instead of sensor data is always there, but they don't want to treat it like an unsupervised learning model. They want to deterministically build a model that will predict the accident. So they are actually waiting. They have waited for 1 year. In that 1 year, all the cars that have reached their garage, they have tagged all of them as 1. Just before the accident, whatever are the sensor details have been tagged as 1. These are the cars that met with accident, and these are the sensor recordings. Okay. After that, we need zeros. We need the data of non-fatal accident or no accidents data is required. The sensor recordings related to zero. Now that is easy. You take the car, take a round, make sure that there is no accident, take the sensor data. Take the car, go to a highway, make sure that there is no accident, take the sensor data. Take the car, go to a forest, off-road, make sure there is no accident. Like that, wherever those cars were roaming, make sure that you are roaming there as well, but there is no accident. That will give you zero. This is easy data. Without accident data, sensor recordings will be very easy. These are the recordings that are related to zero. These are the recordings that are related to one. This is the data that they have gathered. They have invested a lot of money on sensors, obviously. They have invested a lot of time. They have put all the infrastructure, everything they have to do just to get the data. Because we know any model is as good as the data. If the data is not good, the model is not good. They have gathered all this data. You know what they have done? They ran a data science competition on this. They gave this data to the world. They told that all the data scientists around the world can take our data. You can build your own model. The best model wins the prize money. That's what they told. Take this data, build a model, and the best model, the highest accurate model will win the prize money, is what they have told. Do you know any website where data science competitions are held? Have you ever heard of any such websites where companies come there, post their data science competitions? Any website that you heard of late? There's a very famous website called Kaggle. Kaggle is a website where data science competitions are held. There are other websites too, but this is the famous one. This competition was held with the name of Stay Alert Ford Challenge. Okay, I have given you some background. You can also see the data and all that. Physiological, environmental, vehicular data. Prize money was $950. 11 years back, this competition was held. If we have to participate in that competition, if we have to win all that prize money, what should be our approach? Let us see. Have you understood the problem statement? Shall we now go to the data and download it? Overall problem statement was clear. What is the problem statement? We have to build a model. We have to build a model that will take these sensors as input. This model will take sensor as input, and it has to predict in the next second whether there is going to be a fatal accident or not. That's what model input is sensor details. Model output is fatal accident going to happen or not. Let us see how to build this model. All of us, we will go to our class file. Go back to classwork. Random forest is the session. Random forest code. Pasting the code file in the chat window. Okay. Data importing first. Import the packages, import the data, get all the features. What are the features? Sensor 1, sensor 2, sensor 3, all the sensor details are the features. So what are the features? Sensor 1 to sensor 22. What we will do is, before jumping onto the random forest and all that, let us give a chance to decision tree, see what a decision tree can do. Let us build a decision tree model. Look at the accuracy on train data. Look at the accuracy on test data. There is not much of discussion about the decision tree. Yesterday we have seen how decision trees work in depth. So directly build a decision tree. Tell me the accuracy on train data and test data. After that, when we reach the random forest, once again I will recap the important hyperparameters. All of us together we will fine tune, and we should be able to fine tune by ourselves. But for now, first build the decision tree. Tell me the result of the decision tree. What is the accuracy on train data? What is the accuracy on test data? The decision tree gives us 86 on train data, 85 on test data. Fair enough, like 86, 85, we can accept it. Overall, we will say my model is around 85% accurate. After this, wait, don't go ahead. All of us together will discuss the parameters, then we'll start the random forest together. Let's wait for others to complete this. So you give me a notification when you're done with the decision tree. Let's wait for others to quickly complete that. Are you done with decision tree? Is there any issue while working on decision tree? Anybody? Shall we discuss the random forest now? Ready, all of you? Same page, all of us are on the same page? Quickly stop me. Is there anyone who's still working on random forest or in a decision tree, or the code is not opening, or any issues in the code? Quickly stop me. Otherwise, I'll start random forest. All right. In random forest, we have to give some hyperparameters. We can't work with the default values. Tell me what is the first hyperparameter that is in your hand which you need to fine tune? What is the first hyperparameter when it comes to random forest that you need to fine tune? The number of trees. Okay. The number of trees, we denote it by K. Okay. The number of trees K. Number of trees K, this should be a very large number or a very small number. What should be this in general? Number of trees K should be a large number. What is the range that you can try when you are working on any new problem? If you are unaware of what is the optimal number, what is the range that you can try? For me, for most of the problems, a range of 50 to 300 works perfectly. First try 50, after that you go to 75, after that you try 100. Keep on increasing only. That's the first suggestion. The second hyperparameter. What is the second hyperparameter? The number of features denoted by P. What should be this number? What is the suggested value that you can try? Is always 4 to 7 standard? Is always 4 to 7. Let's say I have 300 columns in my data. If I have 300 columns in my data, is always 4 to 7 standard? Think about it. What is the suggestion? There in that example, I told 4 to 7 because what was it? Where was it? Yeah. There were 30 columns here. That's why like square root of 30 plus or minus 2, isn't it? That was the trick. So 4 to 7, in that problem it works. Here, what is T? The number of columns T. What is it? Number of columns T. What's that? There are 22 features, right? 22. So square root of T plus or minus 2. Square root of 22. 5 plus or minus 2. Something like 4 or 5 or 6 or 7. In this example, somewhere like 3 to 8. 5 plus 2 or minus 2. Something like that. Or let me take a slightly higher number. Somewhere here. Somewhere 4 to 8. Or but don't take this 4 to 8 as a number that will work definitely everywhere in every problem. So the rule here is, the trick here is square root of t plus or minus 2. T is the overall number of columns. Here our t equal to 22 senses were there, right? That way. The third one is max depth, that is there for every decision tree. Max depth need not be fine tuned. You can leave it as a static number. Max depth, the suggested value is slightly higher than the single tree. Go to your single tree. What is the depth of this decision tree? Go to this tree. All of you go back to your code. Tell me what was the depth that you have tried for this single tree. 6. Since we are using only four columns here, 4 or 5 or 6 or columns, okay, somewhere around 4 to 7 columns is what we are using. What you can try is, okay, you can try slightly higher depth than this. That is not risky. Why it is not risky? Since I'm not using all the 22 columns, if I'm using only 7 columns, even slightly higher depth is possible. 50% higher than this you can try. 6 is the single decision tree depth. You can try something like 8 or 9 or 10, 8 to 10. Somewhat 50% higher. 6 plus 50% is 3, 6 plus 3, 9, around 9. 8 or 10 you can try, 8 or 9 or 10. Why slightly larger trees need to be tried? Because we do not have the risk of overfitting if we are using lesser number of columns. These are only suggested numbers. The real answer may be around this or maybe a little far away from these as well. With all these configurations, you have to look at the train accuracy. You have to look at the test accuracy. Make sure that you are not overfitting. Make sure that you are not underfitting. Then only you can finalize and find out the final hyperparameters. What I want you to do right now is try this number of trees. Here the parameter in Python is known as n estimators. Try the features, it is known as max features. Try the depth, which is max depth only. Try all this. If you can beat 86 and 85, let me know the answer. So in the chat window, you're going to put 5 numbers: trees, features, depth. With these 3, train accuracy, test accuracy. So in a single message only, put all these 5 numbers. Then I will write down here if they are beating the single decision tree, which means if the accuracy is better than single tree, I will write them down here. Go ahead, all of you. Try these numbers. Try to fine tune by yourself. Try to put 5 numbers inside a single message. So with the trees 30 from Kanishka, the trees are 30, max features are 6, depth is 8, train accuracy is 89, test accuracy is 88. So my suggestion would be, try to make it. What is the range that we suggested? What is the range? Range is 50 to 300. It has to be a very large number. Sometimes 30 may work, but in general, for a wide variety of problems, if you want to have right numbers, maybe try this as 100. That's a suggestion. This looks good. You can leave it as it is. This one maybe you can try with 9 or 10. You may get slightly better accuracy. That is a suggestion. So go ahead, retry it. Anyone else got better than decision tree? Put all your 5 numbers. I'll write them down here. Sudhakar, 100 decision trees. Pretty good. This is a good number. Max feature 6. Good number. Max depth 6. Bad number. Usually this should be what? What is the suggestion that we gave? Max depth should be around 50% higher than the single tree. Maybe 8 or 9 or 10 must be tried. Tell me what is the train and test accuracy that you got with this combination? Try to put all the 5 numbers in the single message. Otherwise these messages are getting mixed up. Everyone, try to put your configuration along with that train and test accuracy also. You try to put it there, okay? So that I can write them down here. Another configuration, 100 estimators. Good. Max features 6. Good. Max depth 10. Good. No suggestion here. Looks perfect. Looks perfect. Almost looks perfect. 92 and 90. This can be pretty much finalized. Even if we try whatever we try, almost this is the accuracy that we may get. Okay. Try to put all your values, 5 values inside a single message. Okay. Kirtana. 100 trees. Very good. 6. Good. 9. Not bad. 91. 89. Almost 89, 90 is not considered as a huge difference. 88 I'll erase because there is a scope for improvement. 1% is fine. So the only suggestion that I can give is maybe try 10. Maybe little bit 0.5 or something will increase. It will look like right now it may be 89 point something. You can push it to 90, but overall 89, 90 considered as the same thing. Vidya. 64 is an estimators, not bad. 8 features, not bad. Max depth 10, not bad. 93 and 90. Fine, it's fine. If we want to be on the safe side, let's say I don't want to have more gap, more than 90% gap if I don't, more than 3 points if I don't want that gap. Maybe slightly reduce this by 1 point, either this or slightly reduce this depth to 9. Then you may have 90 to 90. Usually 92 on train data, 90 on test data is a comfortable situation to have rather than 93 and 90. Okay. Otherwise, this whole thing looks good. Okay. Even 3 points difference also kind of we are very strict on it. That's why. Another configuration. 125 trees, 9 features, 11. Slightly higher, slight risk of overfitting. 94, 91. Maybe slightly try to address it. Okay. We would rather like to see 93, 91 or 92, 91 rather than 94 because on the train data it is 94. I expect test also to be 94 or 93 or 92. 91 seems to be slightly away. The strict rule is 5 points, but here also like it is 3 points. Maybe what we can do is there is no real happiness in just looking at the train accuracy. Our model has to be good on the test as well. So, and it has to be nearby as well. Maybe slightly reduce this, slightly reduce this. If you are getting 90 to 90, that is also fine. Okay. Slight little zone of overfitting it is entering. We are trying to avoid that. That's it. Anyone else who got the result? Anyone else? You must get 89 or 90 on the test data for sure. On the test data, 89, 90 is the benchmark. The right answers can be multiple answers. You just need to be near to one of the answer. Everybody, tell me your result. What is your final configuration that is giving you either 89 point something or 90 on the test data? Go ahead. Reduced P by 2, max depth by 2, got 88, 89. Try to fix it, Vidya. Fix that. Try to have the final optimized values. Anyone else who got the result? Any other combination that I can write down? Try to fix it. Has anyone tried crazily high number of trees? 300 or 400. What happens is, it's okay, even if you build more and more trees, it will not overfit. It will actually well generalize only. That is why number of trees is as high as possible. It's not a very big risk there. Okay. Even you can build a really large number of trees, still you will get 90 only on the test. Has anyone tried it? Very large number of trees. But if you try very large depth, then you will see the overfitting very clearly. If somebody tries depth as 20, then definitely you will see clear overfitting. Maybe if you want to check when does this random forest get into overfitting, keep these things same, but try the depth as 20 or 30 or 40. You will see the model is overfitted clearly. You may get nearly 100% accuracy on train and 90 or something on test. Everyone else, you also put your results. Only 4 or 5 people have kept it here. What about others? Have you fine-tuned? Have you finalized? If yes, put your 5 values. Kishore has tried 300 trees. Pretty good. No doubt about it. 6. No question about it. 10. Good. 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 No need of any modification. 92. 90. Pretty much final. No second thought about it. As we discussed, the hyperparameter values, the optimal values are not just a single combination. There are a range of values. If you are near to the right combination, then you are through. Fine-tuning these is not a very difficult task. But nowadays, there are so many tools, there are so many packages that they have come. They will take care of all this fine-tuning. 100% automation is achieved in almost all the machine learning models. Have you ever heard of Auto ML? Auto ML. Okay. that is automatically doing all these things on its own. N estimator says 81, max feature says 19. Now this is odd. If there are 22 features, taking 19 out of them is not a good idea. It may work here, it may not work in future. Usually what is the suggested number? Even 9 is also high. What is the suggested number? Square root of 22 plus or minus 2. Let us take 4.5 plus or minus 2. Something like 4 or 3, 4, 5, 6 would be better. Because maybe in this problem, few numbers may work. I'm talking about much more generalized manner. Okay. 9. And the max depth is how much? Max depth is 8. So for this, you got 90 and 89. My only suggestion would be slightly decrease it, maybe by one number, 8 or something. Slightly increase it by either 9 or 10. You may push this number to 90 as well. There is a little scope here. Okay. Otherwise, this model overall we are near to the right values. Only thing is, while we are working on more and more problems like this, we tend to develop some tips and tricks of our own, and then finally, like after solving 10 or 15 problems on random forest, we'll be very much comfortable for fine-tuning these. However, in the beginning, you can take some of these rules, okay, and then search around these. That is the story of random forest. Finally, what I want to conclude is this one. If random forests are giving better results always than decision trees are there, random forests are there. Comparatively, random forests have a huge advantage. What is it? They give better accuracy. Accuracy is more. Okay. If random forests are always giving better accuracy than decision trees, why do we even need decision trees? Why can't we simply always use random forest? Okay, we may get that question, right? Accuracy is more in random forest. Why do we even use decision trees? Let us talk about the disadvantages of random forest. Tell me, what is the first disadvantage that is strikingly visible in random forest compared to a decision tree? What is the first disadvantage in random forest? A computational complexity. Here you are building decision tree. The advantage is it is pretty simple. If I ask you to draw a decision tree, can you draw it and show it to me? A single decision tree? Is it easy for you? Have we drawn a decision tree yesterday? Have you shown me how a variable is picked? Which side is class 1? Which side is class 2? All that we did. Is it possible to draw all these 300, 400 trees, all these 200 trees in random forest? Can you draw it? Interpretability, interpretation. Is it easy? Interpretation, which variable is entering where, what is its impact on the target variable, which are the variables that are highly impactful, which are the variables not impactful, individual variable impact. Can you do all that in random forest? No. Here it is clearly interpretable. You can interpret easily. Decision tree is a simple model. You can clearly interpret and show what is the impact of each and every variable, whether a variable is entering the tree or not. All those things are can be easily analyzed and understood. Whereas in random forest, it is complex. It looks like a just model black box. This is just a black box. Okay. What happens inside that model black box, we will not get to see. Whereas decision tree is not a black box. What happens inside a decision tree, which variable is entering and all that, you can explain easily. That is why if you are building a model that requires interpretability, it requires simplicity, you are okay to sacrifice the accuracy. Even if I have less accuracy, that is fine. But I want to build a strategy based on the variables, then you go with decision tree. That is why the reason why in marketing and all that customer segmentation, decision trees are used. Because there we will be building the strategies based on the variables, we'll be studying each segment. But there are some cases. Now tell me, for this Ford, if you want to win this competition, are you going to build a decision tree which is slightly less accurate but high interpretability? Or are you going to build a random forest which is very high accurate but black box model? What do you think Ford is going to give an award for? Less accurate model which can be interpreted easily. High accurate model, it is a black box. Obviously, Ford will give prize money to the only that person who has given the highest accuracy. The reason is they don't care what is the impact of sensor 1, what is the impact of sensor 2, what is the impact of sensor 22. They are not interested in all this. Whatever you want to do, you just do it. Whatever you can, you do it. At the end of the day, I want to have higher accuracy. If you are giving me 5% more accuracy, 86% is decision tree, 85% is decision tree, 90% is random forest. If you are giving me 5% more accuracy, then I can save almost 5% more lives, isn't it? Now that is invaluable. So definitely random forests are preferred in certain cases. This is the call that you have to take when you are solving a problem. You understand the client's problem statement. Then you suggest him, you know what, if you are going to build the strategies that require a simple strategy that requires a lot of interpretation later on, then we will go with decision trees. Looking at your problem statement, I feel that we just need highest accuracy, then you suggest random forest. This call is not a strict call. This is based on the business context. You have to make that call, which model to choose in this scenario between these two. Alright. So the advantage of the decision tree is it is fast, it is simple, it is easy to interpret. Disadvantage is less accuracy, slightly less accuracy. Advantage of random forest is that its accuracy is more. Definitely any day it is greater than decision tree. Disadvantage is computational complexity, interpretability. Random forest is known as black box machine learning model, black box method. What happens inside the model, you will not get to see easily. With that, we will conclude random forest. We will take a break. After that, there is one more ensemble model called boosting. We are going to discuss what is boosting. After that, there is a proper conclusion session we'll have. I'll take all final questions and I'm going to give you a plan for what are the next steps that you can take after completing this course. What are some of the good resources that I have found on the online? I'm going to share them with you in future. If you want to study further, those resources are going to help you. There are some location where you can get the data sets and all that. That also I'm going to share with you. Okay. We'll have a proper conclusion. Be ready with all the questions for that conclusion session as well. So that is random forest. Before getting into the lunch break, are there any questions, anyone? Any questions? If there are no questions, let us meet at 1:50 p.m. and then get into the next chapter. Let's break. Welcome back, everyone. Once you're back at your desk, send me a message. Let's give a minute for others to join in. Now, the last topic for this program is boosting, famously known as GBM, gradient boosting method. Before I get started with boosting, I would like to take some questions. If you have any questions related to any of the topics that we have discussed until now, please go ahead. If there are any unanswered questions, please let me know. All right. We have discussed one ensembling technique, which is random forest, which is a special case of bagging. There is one more ensembling technique called boosting. Bagging and boosting, both are ensembling techniques. Whenever you think of ensembling, you have to imagine that there are several models that are being built. Their results have been collated to get to the final output. Generally, that gives slightly better accuracy. Boosting also does build several models and it does collate the output. Let us understand boosting in depth. The logic of boosting, the theory is very easy. Boosting uses a particular trick. If we understand that trick, then the rest of the whole theory in boosting is a very easy, flow. Let us understand what is that major trick in boosting that people use to get better accuracy. Let us suppose you have a data X and you have the target variable Y. Apart from cluster analysis, all the other algorithms are supervised learning models only. Okay. Only unsupervised learning model that we discussed is cluster analysis, and there are no other models that we discussed in this classroom. All of them are supervised. If you have data of X and Y, and X can be multiple columns, feature 1, feature 2, and so on, multiple features, and if you have a target value Y, usually you tend to build a model. Let us suppose the model equation is f of X. Then you can say I can predict the value of Y using f of X. I'll get the predicted values. And when I get the predicted values from model, I may get some error as well. This is what we used to do to predict Y. I built this model and this is a leftover error. Sometimes the error is positive, sometimes the error is negative. Y actually equal to Y predicted plus some error. Usually we tend to stop here. Usually we tend to build one model which is f of X and we tend to stop used to live with this error. You know what is the trick in boosting? There is only simple trick applied on top of it. What boosting tells you is don't worry about building this model, one model as the best model. Don't worry about that. Build a weak model. Let f of X be a weak model. Weak models means less accurate model. Less accurate model means higher error is still present. It's okay even if you build a weak model, let there be error. So you have X values You have y actual values. From f of x, you got y predicted values, then you got some error. These are the values of x. These are the error values. What if this f of x is a weak model? What if there is a lot of error still left? What if there are some patterns in the error? What if you can still deterministically reduce the error? You can still deterministically model the error as well. That is the trick of boosting. What if you can actually reduce this error? For reducing this error, you know what we do? We build a model for this error. We will use x as the input. Until now, our output is y, target variable. Now what we will do? We will take the error as the output. We try to predict error using a model, let's say h of x, and you will make slightly lesser error. When you are building this, definitely within this there will be some more leftover error. So your original equation is y equal to f of x plus some error 1. Now we have modeled and deterministically found some error which can be modeled. We model that error using h of x plus some error 2. Now what if this is also weak model, this is also weak model, still there is some error left. Try to build another model g of x. That model again, this error 2 will be less than error 1, which is error 3 is less than error 2. Obviously this error, since you have deterministically found some value, this will be always less than the previous error. Building a model for the error, this error is known as residual. Boosting is also known as residual model building. Building a model for the error, building a model for the residual. Once again, how is it done? If you take a numerical example, it looks like this. You have x, you have y. Usually, we tend to build one model which is f of x. That's it. We live with whatever error that we got out of that model. In this example, x is here, y actual values are these. From model f of x, first model f of x, these are the predictions made by the model. And the error is 10, 40, 30, 50, 14, 30, 20. These are the errors made by the model. Okay. Now, usually we tend to stop here. I have built model f of x and this is the error. Let us be satisfied with this, that whatever is the accuracy of the model, let it be. Now what do? We take this x as input. Let us try to deterministically build a model for the error. Let us try to extract how much ever can be extracted out of this error. Can I model the error? Yes, we can model. Take error as output. Let this be input. Error 1 equal to some h of x. And then that will give slightly lesser error than this one, because deterministically we found something, we modeled some pattern, we found some pattern, and this is the leftover error. So here is the x value, this is the error 1, 10, 40, 30. These are the error values, and these are the h of x predictions. This h of x is predicting error 2. These are the predictions, and this is the leftover error. Look at this. From 10, the error has gone down to 2. From 40, the error has gone down to 5. From 30, the error has, these are error 2. What if I can deterministically model this error as well? Then I'll build another model g of x plus some error 3. Like that, the final model equation will be, you first start with y equal to f of x plus some error 1. Afterwards, you build a model for error 1. So your final model will be y equal to f of x plus h of x plus error 2. Error 2 is less than error 1 for sure. You further model error 2 f of x plus h of x plus g of x plus error 3. This is a weak model. This is also a weak model. This is also a weak model. Definitely, if there is still some error left, what is our next plan of action? What we should do? What is boosting going to do? Weak model, weak model, weak model, collation of three weak models. So it's giving some accuracy, but still there is some leftover error. Then what do? K of x plus some error 4. We keep on doing it. When do you stop these iterations? You keep on, this is iteration 1, iteration 2, iteration 3, iteration 4. When do you stop these iterations? Theoretically, tell me the theoretical stopping point. What is the theoretical stopping point of these iterations? What is the hard stop? Once the error reaches to 0, when there is no more error, then you stop. But when you are building the model, when your error reaches to 0, are we really happy in all the scenarios? Usually when our error reaches to 0, accuracy is 100%, which means there is a huge risk of Once our error reaches to 0, when our accuracy is 100%, there is a high risk of what we need to be aware of. Think about it, all of you. Are you happy when you are building a model, you got the error to be 0? Are you always happy if you get the error to be 0? Invariably, what may happen if you're getting 0 error and 100% accuracy? Think about it, everyone. What do you think will result in? When we are building the model, we got the error to be 0. Most often, what will happen? We will have the issue of overfitting, isn't it? Yes or no? Can you recollect it? Because the more data that is used for building the model is called trained data. On the trained data, error is 0, 100% accuracy. There's a high chance of overfitting. That is why if you run boosting for too many iterations, if you run too many iterations in boosting, the model, boosted model will be overfitted. Let us suppose if the number of iterations or optimal values are 5, if the number of optimal iterations are 5, but if we have run too many iterations, if we have run 50 iterations, the model will overfit for sure. But if I have built only two models, if I have run for only two iterations, two weak models and collated them, then there is still some scope for the error to reduce. So this will underfit. That is why the number of iterations in boosting is a hyperparameter. Too many iterations will lead to overfitting. Too few iterations will lead to underfitting. The number of iterations need to be optimal. We have to find it. Since anyway we have the hold of train data and test data, easily we can find out if we are getting into the range of overfitting, easily we can reduce the number of iterations and stop at a point when we have max accuracy on train, matching accuracy on test, we can find out the number of optimal iterations. That's not a very difficult task. Number of iterations is in our hand. It's a hyperparameter that need to be fine-tuned. The critical point in boosting is once the error is found, that error will be modeled, whatever can be deterministically found. Here in this demonstration, I'm showing that the error is reducing a great deal, but in reality, what happens is errors reduces only a smaller amount. From 10, it may go to 9.5. From 40, it may go to 38. From 30, it may go to 29. It may not decrease this much amount, which means slightly higher number of iterations are required in real life because we want to build all these models which are kind of weak models, less accurate models. Boosting is also known as residual model building algorithm. Residual means error. We are building a model for the error, for the residual. That is the only trick in boosting, building the model for error. By collating all these models, by combining all these weak models, when you compare with a single model, when you build a boosted model, you're going to get a 2 to 3% better accuracy. However, in boosting, you may fall into the trap of overfitting. You need to avoid it. If you see the actual theory, how it happens in the background, this is how it happens. Initial data points are x1, y1, x2, y2, x3, y3, xn, yn. These are all the initial data points. X can be multi-dimensional, multiple features are also possible. For this, you build the model y equal to f of x. Obviously, this f of x, since it is a weak model, you expect definitely there will be a lot of error in the first model. Then the next time the data points will be x1 error 1, x2 error 2, x3, xn error will be the data points, which means you are going to model for this error y equal to f of x, model for this error, which is like h of x plus some error 2. Always error 2 is less than error 1. It will never happen that these errors will be more than this error because we are modeling it. Whatever is the fraction that is taken away, this is remaining. Maximum it will be 0 and then error will be full. But definitely when you are modeling something, this error will be less than the previous one. After that, y equal to f of x plus h of x plus for error 2 g of x plus error 3. You keep on doing like this, but you have to stop at the optimal number of iterations. If you run for too many iterations, overfitting will happen. Too few iterations, underfitting will happen. Finding out the optimal number of iterations based on the data, we have to find that optimal value. That's the job of a data scientist to fine tune it. That is the overall boosting theory. I'll once again go through this theory, then I'll give you a few more details of this. So what is boosting? Usually you have this data set. Imagine there will be several features x, and then you're predicting the target variable y. You tend to build a model y equal to f of x, and there will be some error. F of x will give you predicted values. This will be the error. So x value as it is, y value call it as y actual, f of x predictions call it as y predicted. These are the errors. A major point in boosting is take x as input. What if there is some pattern in the error? What if something can be deterministically modeled in boosting? If you are getting that questions in your mind, go ahead, build a model. Try to use x as input, try to use error as output. Try to build a model for the error y equal to h of x plus some error 2. So final output will be f of x plus error 1. Error 1 has been modeled as h of x plus some error 2. What we will do is we will model for that error and then try to deterministically find something like g of x plus error 3. Deterministically find k of x plus some error 4. However, the number of iterations that we are running here, they need to be optimal. If you overdo this, we may fall into overfitting. In the background, we don't need to do all these model building one by one, one by one. There will be a function which is called boosting function. It will automatically take care of all this. All that we need to do is send the data. It is the number of iterations, mention the number of iterations. This whole process will happen in the background. Initial model will be y equal to f of x plus some error 1. Second model will be y equal to f of x plus h of x plus error 2. Now that is the original theory. But when we come to real world problems, there is one more extra feature that has been added to this. Look at this carefully. Important point. When we have built this model second time, instead of taking h of x values as it is, we multiply the h of x values with rho. In the third model also, f of x plus rho into h of x. Let's say if we are building g of x, multiply that with rho into g of x plus some error 3. Like that, you multiply all the values of h of x, g of x, k of x, later on all of them. You are going to multiply with a factor called rho. Rho is known as shrinkage. Rho is also known as learning rate. At some places, it is also known as ETA. Usually, rho is a number that is set to be between 0.001 to 0.1. Always rho is less than 1. That means if h of x is predicting something to be 20, if rho equal to 0.1, instead of taking 20, what number I'll consider here? The original prediction I should take is 20. Instead of taking 20, the number that I'll consider is 20 into 0.1, which will be 2 only. H of x is suggesting me to take 20, but I am taking 2 only. What effect that it will have? Will the error reduce suddenly or it will only reduce a little bit? Here, error 2 will still be high. It will be less than error 1, but it will not reduce drastically. It will reduce only a little bit of amount because at the place of 2, at the place of 20, I have multiplied 20 with 0.1. I am taking only 1/10 of it. What this will do is this will make this error still a large number. Definitely less than error 1, but still a large number. By introducing rho, it will prolong the algorithm. And prolonging the algorithm is very important in boosting. I'll show you why it is important. So here what we are doing, original equation is y equal to f of x plus h of x plus error 2. In place of h of x, I'll say rho into h of x. Rho is usually between 0.0001 to 0.1. Rho is always less than 1. Okay. For example, if h of x is suggesting me to take 20, I will multiply it with rho. Let's say rho is 0.1 in an example. Rho into 20, 0.1 into 20, I'll take 2 only, which means this error 2 will be still high, which means this algorithm will be prolonged. For example, if we go back to our own example, as it is, if you take with rho equal to 1, so what did we do? These are the errors, initial errors. Check this out, initial errors. You built the model. This is a h of x prediction. 10 was the value, the predicted value by h of x is 12. 40 was the value, minus 40 was the value. H of S prediction is minus 45. So when you have made these predictions, the error from 10 it has gone down to 2. From 40 it has gone down to 5. From 30 it has gone down to 2. From 50 it has gone down to 5. Drastically the error has reduced without any row. What if I introduce row and row equal to 0.1? What will be the number here instead of 12? What I will take? These are the H of S predictions. If I multiply them with row equal to 0.1 instead of 12, what will be the number here in this place? Instead of 12, it will be 1.2. Instead of minus 45, it will be minus 4.5. Instead of minus 32, it will be minus 3.2. Like that, these are the new numbers with row equal to 0.1. These are the new numbers, which means the error will be less than error 1, but it will be still high. Error earlier from 10, earlier it has gone down to 2, but from 10 it has gone down to 8.8. From 40 earlier it has gone down to 5, now it has gone down to 35. Error reduced but not a great deal. Reduced but not a great deal. Error is reducing slowly. That means to achieve whatever I have achieved with rho equal to 1, whatever I have achieved in one step, with rho equal to 1, whatever I achieved in one step, with rho equal to 0.1, how many steps it will take to achieve the same error? How many steps it will take roughly? Can you make a rough guess? Whatever error I reduced with rho equal to 1 in within one iteration, now with new value of rho, which is 0.1, how many iterations will it take roughly? Since I'm taking only 1/10 of h1, h of x, it will take roughly 10 iterations, isn't it? Makes sense? Think about it. Roughly 8 or 9 or 10 iterations it will take. Minimum 10 iterations, or roughly on an average 10 iterations it will take. Because why? I'm taking only a part of h of x, exactly precisely 1/10 of h of x. Maybe if not strictly 10 iterations, maybe 8, 9 or 10 iterations is what it is going to take, whatever I achieved in one step. That means I'm going to prolong the algorithm. Earlier with rho equal to 1, if the algorithm ends in 8 iterations, to achieve the same accuracy, how many iterations I have to run with rho equal to 0.1? I know that with 8 iterations I got the best answer. With rho equal to 0.1, how many iterations I should run? Since it's almost like each iteration takes 10 steps, almost 80 iterations I have to run. That much prolonging will happen in the algorithm. Why prolonging is important? Here is the reason. The reason why prolonging is important in practical scenarios, very, very useful, very important. Why this learning rate, or these are known as learning rate, shrinkage, or ETA, it will prolong the algorithm. Why this prolonging is important in boosting? We need to understand that. Let us suppose this is your result. Imagine you have worked with rho equal to 1 and the number of iteration. At the end of one iteration, train accuracy, test accuracy. At the end of two iterations, train accuracy, test accuracy. Everything is given to you. For solving this problem, can you tell me optimal number of iterations? Optimal iterations. Optimal number of iterations. Optimal number of iterations here. What do you think is the answer? Optimal number of iterations. Will you run for 5 iterations or 10 iterations, 6 iterations, 7 iterations, 2 iterations? Optimal number of iterations for this problem. Carefully look at it and let me know. All of you try to participate kindly. Optimal number of iterations are how many here? If I go for 9 iterations, I got 100% accuracy on trained data. So I can go for 9 iterations because we have 100% accuracy. Is it a good idea? Can I stop at 9 iterations? No. Accuracy on the test data is 60%. This is a clear case of overfitting. What about 8 iterations? 95, 75. 75 is decent accuracy. Can we finalize this? Because this is a decent number, right? It's okay, right? A 75 is near to 80. Can we say I got a decent model? No. We have to look at 95 versus 75. There is a large difference, overfitting. If I stop at 3 iterations, 30 and 29, there is no gap between them. 30 and 29, this should be fine, right? 1% is fine, right? Or let's say if I go for 4 iterations, 45, 45, both are same. Can we finalize these 4 iterations? What is the issue with 4 iterations? 45, 45 looks perfect, right? So here there is a scope for improvement. We may find better accurate models. So in all possibilities, the best number of iterations seem to be, finally we will be saying that we'll be running for exactly 7 iterations. We got a perfect 84% accuracy on trained data, 84% accuracy on test data. This is the optimal number of iterations. Anything below that will underfit. Anything above that will overfit. For me, 7 is the optimal number of iterations. But you know what happened? I got to know somebody used the same data. Somebody used the same data, same features, everything same boosting. But that person has got 90% accuracy on train, 90% accuracy on test. Shocking. Someone else has used the same data, same features, but that person got 90% accuracy on train, 90% accuracy on test. To get 90% accuracy, can I increase the number of iteration from 7 if I go to 8? Will I get 90-90? When I go to 8 iterations, I'm getting 95-75. Overfitting is happening. And how do I achieve it? You know what I'm going to do? This is with rho equal to 1. If I try rho equal to 0.1, whatever I achieved in one iteration, usually how many iterations will it take? If I try rho equal to 0.1. Whatever we achieved in one iteration, it will take 10 iteration to reach this accuracy, 20 iteration to reach 15%, 30 iteration to reach 30%, 40 iteration to reach like that. Whatever you achieved here, it will take almost 10 times more iterations. So this is the result that you will get. At the end of 10 iterations, roughly this much train, this much test. Can you now smartly tell me what is the number of iterations where there is a high chance for me to get 90% accuracy on train, 90% accuracy on test? Is there a chance for me to stop at this particular granular point? If yes, roughly what is that number of iterations that I can try for me to stop at 90, 90, 90 on train, 90 on test? Roughly, where can you find that? If I stop at 70, I'm getting 84, 84. It's a slight underfitting in our case because 90 is possible, slight underfitting. If I go for 80, 95, 75, overfitting. Definitely there must be something in between, something like 74 or 75 or 76. This is the place where you may get 90 and 90. To stop at a much more granular optimal point, if you want to stop at a perfect granular optimal point number of iterations, you require this learning rate to be lower value so that the algorithm will be prolonged. In real life scenarios, if the algorithm is prolonged, you'll be able to stop at the exact optimal point. If the error is reducing very much drastically, sometimes you may skip that particular optimal point. The below it may be underfitting, above it is overfitting. You may not be able to stop at the optimal value. That's why prolonging is important. This prolonging is done by using a parameter called learning rate or shrinkage. Learning rate is in our hand. You don't need to fine tune it. You have to choose a number within a certain range. Once again, what is that range that works for most of the problems? Most of the numerical problems, this particular learning rate works. How much is that? Rho should be between 0.0001 to 0.1. Most of the cases, any number between these two tend to work. That is the story of learning rate. Okay. Now this is a whole story of GBM, which is known as gradient boosting method. But in short, people tend to call it as boosting. This whole theory looks good. GBM tend to give good results also, but people are not using GBM. They are very much scared. The reason is your here GBM suggests that the algorithm should be prolonged. With rho equal to 0.1, With rho equal to 0.1, whatever you did in one iteration, it is taking me 10 iterations. If I would have taken rho equal to 0.01, whatever you achieve to achieve 10% accuracy, how many iterations I'll take now? With rho equal to 0.01, roughly, can you make a guess? 100 iterations it will take. That means to get 90% accuracy, I will take 750 iterations. Imagine 750 iterations, 750 models. That is a huge number. GBM is computationally very expensive. Very, very expensive. That is why people did not really like it. GBM in theory works well. In theory looks good. It gives better results than decision tree. Almost equal results as random forest, at par with random forest. But when it comes to implementing them, building the models, it is not really fast. That is why there has been a new package that has been introduced to solve this problem. XGB it is known as. It is known as XG boost. Extreme gradient boosting. Extreme gradient boosting. In short, it is known as XGB. Some people think XGB is a technique, but that is wrong. XGB is not a machine learning technique. XGB is a package. What it does boosting. Boosting is the technique. Gradient boosting method is the technique. XGB is a faster version of GBM. Both XGBoost and GBM, they follow the same principles of gradient boosting. That means behind the scenes, the theory is same. But what did developers of gradient boosting have done? They have made a number of performance enhancements that will make this GBM much faster. XGBoost and GBM have huge difference in speed and memory. What I can promise is if GBM takes 24 hours for execution, XGBoost will take exactly half of it, 12 hours. Straight away you can save half of it. XGBoost in XGBoost package, they have modified the background code to utilize the processor and cache better way so that it will make faster. You know what is the best part about XGBoost? Even the better part is XGBoost package has a parameter where you can say that use GPU. GPU means graphics card. Usually in our system we have CPU, right? Let's say octa core. Means I have a CPU with 8 cores. Each core will be very, very strong. It can do a particular job. Even heavy lifting also these cores can do. But I have only 8 cores. Parallel processing, maximum 8 I can do roughly. You can do many more as well. But at a lower level, at a overall level, 8 cores are available. Whereas if you go to graphics card, which is also known as GPU, graphics processing unit, there will be so many cores. 1000 cores, 1024,000 cores will be there. Each core is very, very weak compared to CPU. It will be doing a small job only. But these cores are perfect for doing our mathematical array related calculations. But you can parallelly process almost 1000 threads you can run very, very quickly. So XGB, if you have graphics card in your system, if you say use my graphics card, it will be even more faster, 20 times faster. If GBM takes 24 hours, with GBU, XGB takes 30 minutes. Look at the difference. You execute the code now, come back tomorrow if it is GBM package versus if you execute the code now, have a tea, come back, you have the result. XGB with graphics card with GPU is a crazy combination. People got totally, they become fans. Nobody uses GBM original package these days. Everybody uses XGB only. Even we are going to use XGB, but we will see how GBM works once. However, XGB is the name of a package. The original technique name is gradient boosting method. So there will be two packages, gradient boosting method package, slow, XGB package, fast. In future, we'll be using XGB package. That is the story of boosting. When you compare boosting results with decision tree, let's say if you take decision tree, if you look at random forest, they tend to give 2 to 3% lift in the accuracy. If you look at another ensemble method, which is boosting models, these also give 2 to 3% lift when compared to a decision tree. So compared to a decision tree, both random forest and boosting tend to give better results. Between these two, if you compare random forest versus boosting on a wide variety of problems when people tried, both of them give the same accuracy. Given that you're fine-tuning this very well, you're also fine-tuning the parameters here also very well, then you tend to get the same accuracy. Both are equally complex, both are black box methods, so both of them almost give the same accuracy. You can use any one of these, any one. But what I have seen is a lot of people tend to use both random forest as well as boosting. Yeah. It may be improved speed, not able to understand the dependency on the improving quality. You mean to say when you compare it with the GBM or when you compare it with, there is no like the accuracy since XGB, if you look at XGB, XGBoost and GBM follows the same principles. Okay. They follow the same principles. The accuracy won't increase. Only speed will be high. So your understanding is correct. XGB and GBM tend to give the same accuracy, but GBM, let's say, gives you 90% accuracy after 24 hours of execution. XGB with GPU will give you 90% accuracy after 30 minutes of execution. Only speed is the difference, but the background theory is same. Okay, because in the background, XGB is not a different package or XGB is not a different theory altogether. XGB uses the same theory, same principles of gradient boosting. The only thing is we have enhanced the code, internal code and all that to make this much faster. Only speed is the difference between GBM and XGB. Any connected questions to that? So if you ask me for a given problem, whether to go for decision tree or not, or whether to go for random forest, there was a clear distinction. If I want simple model, even with less accuracy, I can go for decision tree. If I want high accuracy, even if it is a black box, I'll go for random forest. But if you want to compare random forest versus boosting, when to use random forest, when to use boosting, there is no such comparison. Random forest and boosting almost equal at all levels. Okay. Either you can use this, either this or this. There is no additional advantage of using any one of these techniques. Compared to decision tree, both of them are equally complex. Most of the people that I have seen in real projects, if they are using boosting model, parallelly they will build a random forest model as well. Okay. Any one of them is sufficient, but most of the times both of them give the same accuracy. Model complexity is also same. The execution time is also same, almost same. Both of them almost equal at various levels. Both of them are ensemble techniques. That is all the theory of boosting. We are going to look into a case study now. But before the case study, I would like to take few more questions. Let us see this case study. So this, okay, let me see the question. We got a question. What are the parameters that we need to change when we are working with GBM and XGB? There are two parameters. One of them is number of iterations. The first one is number of iterations. Number of iterations cannot be, it should not be too high or too low. It has to be optimal. I'm going to tell you how to find that optimal value given a data set. The other hyperparameter is learning rate or Sometimes it is known as shrinkage or ETA or row. This one, we don't need to really fine tune it. If we choose a number, the only rule is that make it sure that it is less than 1. Choose a number between 0.001 to 0.1. These are the two hyperparameters that we need to fine tune working on boosted mode.
So for GBM also we will be using these two parameters. For XGB also we will be
This
using
is
these two parameters.
correct, yeah.
But the difference, I want to know the difference. Like, what will be the change when we go for XGB? Which one we should give for XGB and which one we should use for GBM?
GBM we never use in future. Okay, simple.
Okay, okay,
We use only XGB. Only for the
okay,
comparison that there is some model like GBM
okay,
exists. That's why we are going to do it only once here. Since
okay,
in future, since they both work on the same principle, you can think it like you have stats models, you have sklearn, two packages. Both of them will give the same results, but one of them is
okay,
faster, something similar to that. Okay.
okay, okay,
So GBM and XGB, they take the same parameters. The only difference is XGB is much faster. So obviously, if something is giving equal accuracy as GBM and if it is faster, the whole world is using this only. In fact, some people don't even know that GBM does exist. A lot of people see this boosting method as XG boost method, but this is not XG boost method. But yes, a simple answer would be GBM we will not be using in future. XGB is the one. In fact, in the XGB, when we reach XGB exercise, I'll explain all these parameters once again, okay, with the example. But for both of them, the parameters are almost same.
okay. Yeah, thanks.
Only one extra parameter will be there in XGB. That extra parameter would be like use GPU. The GPU option doesn't even exist in GBM package. In XGB, GPU option will be that extra.
Thank you.
Let us see any other connected questions. I will once again go through these parameters as usual with the case study. We will actually go through that code. I'll once again explain them. Let us see the case study here. Flipkart has shared this video a while back. Apparently, this is their warehouse on the outskirts of Bangalore. If you go to Electronic City, beyond that Electronic City, there is another industrial surge, Jigini or something it is called as Jigini. In Jigini, they have this warehouse. Apparently, these small bots that you see here, they are doing this automatic sorting. Earlier, manually, people used to sort all these items, thousands and thousands of items. His name is Venkat. Earlier, he had to do a lot of process manually. Now they have automated it using these small bots. You know what he does now? He just stands there, pushes all the items, then this bots are taking care of this sorting automatically. So next time from Flipkart, if you receive a wrong item, don't blame anybody. Blame this software, whomsoever has written this bot, okay? Anyway, we're going to work on a similar problem. We don't have the data from Flipkart, but we have a data from another e-commerce company called Auto Group. Their problem statement is slightly different, but interesting. They have a shipyard. In their shipyard, they receive a lot of boxes. They're also an e-commerce company. In their shipyard, every year, millions and millions of boxes they receive. Okay. Inside a box, there can be a TV. Inside another box, there can be a camera. Inside one box, there can be a mobile phone. Inside another box, there can be a tablet. Like that, there are 9 categories of items. Personal care is one category. TV is another category. Camera is another category. Okay. Apparels, mobile phones, tablets, iPhones, like that. 9 different categories of items can be found. 9 different type of boxes are there. Okay. Now for every box, there are 100 specifications. Spec 1, Spec 2, specification 1, specification 2, specification 3, and so on, specification 100. With all these specification, what does that box contain? Height of the box, width of the box, volume of the box, surface area of the box, like that, weight of the box, with all these specifications. Is it fragile or is it like rough and tough? Like that, all these 100 specifications. Then final item category with all these specification, it's a TV. Spec 1, Spec 2, Spec 3, Spec 4, Spec 5 with all these specifications. This is a camera. With all these specifications, this is a mobile phone. 100 specifications, what item it contains. Like this, they have gathered the data. Large data set they have gathered. Otto Group is that e-commerce company name. They have this data now, 100 specifications about every box and what actually that box contains. They want us to build a model on this. The major idea is not to really 100% automate it like Flipkart. Earlier, they have to do a lot of manual assortment. They want to just add one more layer automatically, machine learning way of assorting, doing the assortment automatically. Maybe they'll deploy it on a conveyor belt. And then if the box comes on the conveyor belt, all these 100 specifications will be taken. Automatically, we have to predict what category it is. It will be pushed to the right container. Now, this is a different box. It should be pushed to the different container. At least if it does, if this machine learning model does the basic segregation, remaining on top of it, we can employ some human beings to actually do some of the misclassification if there are any errors. Those misclassifications can be segregated by human beings with quick visual inspection. But overall segregation, the model that we are going to build expects us to take these as inputs, 100 specifications, predict what is the item category. This is the data, pretty good data, interesting, rich data. This company has run another Kaggle competition. This is a different company altogether. But these people have run this competition with a good amount of prize money. So you will see a lot of people competing for this. $10,000, even if you spend 1 month on model building, it is almost like 6.5 lakhs. After tax and all that, we'll get like 4 lakhs, which is a good amount of money for a model. I have given you some background. You can read the rest of the things. The competition name was Otto Group Product Classification Challenge. Classify the products into right category. 6 years back competition, 3,000 teams participated. There can be washing machine, there can be a sandal, there can be a TV, there can be an apparel. And we have to do whether it is class 1 or class 2 or class 3 or class 4. It's a multi-class classification. Multiple classes are there in the output. Data is also given. You can download the data. And then if we are participating in this competition, if we have to win it, let us see how do we do it. Okay. What we will do is we will not directly jump onto GBM and all that. First, we will build a decision tree. What is the advantage of the decision tree if you are building a decision tree model? There are advantages too. What is the advantages of the decision tree? Decision tree is fast. Decision tree is easily interpretable. But what are the disadvantages that you will see? Disadvantages. Try to highlight the disadvantage of the decision tree if we use for this model. Less accuracy. Especially if the model is having multi-class classification, decision tree will have even lesser accuracy. Then I'll go to GBM as a solution, gradient boosting method. What is the advantage of the GBM that you will see? What is the advantage? What is the advantage of GBM? GBM will give you more accuracy, significantly more accuracy, especially for a complex problem like this. But immediately we have to write down the disadvantage as well. What is the disadvantage? What is the disadvantage? Computational complexity. It is damn slow. Comparatively, it is very slow. Then as a solution to this, the one that we will be using in our future, we will not be using GBM. will be using XGB. What is the advantage of the XGB? It will be more accuracy. More accuracy in the sense almost same accuracy as GBM. But the bigger advantage is it is fast as well, faster than GBM. So in future you will be using XGB only, but in this exercise let us do the comparison also so that it registers in our mind. That's why we are doing it, even though you're not going to repeat it in future. Let us go to the code file. Class work, boosting, code. I have given the link in the chat window. Import the packages. After that, dataset. Let me check if there are any other sessions running. Boosting is the only session that is running. This is the data. These are some sample data points. 100 specifications and the target. Target is category is the target. Specification 1, 2, 3, 4, 5, spec 100. Category personal care, mobile phone, appliances. In the target variable, which is target variable here, Y variable name is item category. If I do a value count, if I do a frequency count on the category, there are tablets, there are personal care items, appliances, laptops, camera, accessory, iPod, TV, mobile phone. Nearly there are 9 categories. Tablets, personal care, appliances, 3. Laptops, camera, accessories, 3. iPod, TV, mobile phones, 3. 3, 3, 3. 9 categories are there. So this is a multi-class classification problem. The output could be given any one input. The output could be any one of these 9 classes. Create the X-train, X-test, Y-train, Y-test. These are all the features. Spec 1 to specification 1 to specification 100. There is nothing really hard to discuss about decision tree. We have already seen it yesterday. But the only thing that you will see is decision tree gives lesser accuracy, 63 and 62. Then comes the gradient boosting method. Compared to decision tree, GBM will give you better accuracy. But the only thing with GBM is time consuming. Decision tree took just a fraction of a second. GBM is telling that it takes around remaining time is 3.13 minutes. And this is training loss. Usually loss means error. So internally some error is calculated. It is reducing that error iteration by iteration. We have executed for 100 iterations. After 100 iterations, it will give us the result. So it is going to take around 3 minutes time. You also keep it for execution. After that, we will all move to the XGB model. I'll go through these parameters and then together we will execute XGB model. Okay. Let this GBM first complete the execution. For me, it is still executing. Must be the case in your system as well. All of us are using fairly similar space from Google Colab. It took like 70 iterations for me right now. 80 is also done. Usually it takes all those iterations, but since the error is reducing lesser only, at every 10th iteration it is displaying us, but it is running the rest of the iterations as well internally. Hundred iterations run 185 seconds, 3 minutes. Accuracy from decision tree was 63%. Boosting accuracy is 80% on the train data, 78% on the test data. Overall, I can say 78. By the way, until now, the confusion matrix that we have seen is 2 by 2. But now why there is like 9 by 9? Why the confusion matrix is 9 by 9? Is it a random number or is there a reason for this confusion matrix to be exactly in this shape of 9 by 9? Because in the target variable, there are 9 categories. Predicting TV as TV, predicting apparel as apparel, predicting mobile phone as mobile phone. There are 9 classes in the output. It's a multi-class classification problem since there are 9 classes. So all the diagonal elements. Earlier we have only binary classes. Earlier we have only 2 classes. The output can be either 0 or 1. That's why 2 by 2 confusion matrix. Now it will be a 9 by 9 confusion matrix. Obviously GVM beats our decision tree model with a great margin, almost 18% more accuracy. Definitely these kind of problems, we don't worry about the model interpretation or model explainability. We worry about the model accuracy because we want to do automatic segregation of the machines and all that. When it comes to machines, the physical machines, automated machines, there you want more and more accuracy rather than more and more interpretability or anything. Then comes the XGB model. I'll wait here first. I'll wait for everyone to complete the GBM. XGB together, we will rediscuss the parameters, then keep it for execution. Go ahead, all of you, first complete GBM. Once you're done with it, send me a message. Then all of us together will start XGB. Couple of us are already done with this. Let's wait for others to quickly complete that. The question is learning rate specified when we are building the GBM model? Later on in the XGB, we are going to specify the learning rate with the ETA. Here we left it to the default value in GBM. So within this gradient boosting classifier, within this function, there is a parameter called learning rate. Default value, I think it assumes to be 0.01 or something. Let us see what is the default value in this one. Learning rate 0.1 is taken as a default value since we haven't mentioned anything. So it will be taken as 0.1 in this parameter. I'm trying to highlight that it is loading and going off. You can also try that. Try to keep your cursor here and press control. Then you will see the parameters in there. Learning rate is 0.1. By default, n estimators, number of. All right. Now, when you start XGB, usually rest all algorithms that we worked until now, they take the data frame as the input. They take the usual pandas data frame as input. What XGB tells us is, you give me matrix. There is something called a D matrix, which is XGB specific. You have to take your data frame, convert it into D matrix format. You have to convert the data into matrices and send it to XGB. That is a demand by XGB. You have to send the train and test data in the matrix format. Why you need to send the data in this particular format? Because XGB feels that with matrices it can work much faster rather than data frames. Data frames, pandas data frame objects, they contain several other objects as well. Internally, they want to avoid all of them. They want to keep the lighter version, which is just a flat matrix file. So no matter which data you're working on, this step remains the same. You have to convert everything into parameters are the ones that are very important. Look at this, all of you. The first parameter is max depth. What should be the max depth value when you are building GBM or XGB models? The max depth that you should give. Look at this, I got a warning. It says you are connected to GPU runtime. So basically, if I go to Google Colab, in the runtime, for me, it is connected to GPU. Even for you, it should be connected to GPU only, I think. Runtime, change runtime type GPU. It is saying you have GPU connected, but you are not using it. Do you want to change it to standard type? We can ignore that warning. Let us focus on parameters. Max depth. Max depth should be slightly lower than single tree. Okay. Slightly lower than, why is it going here? Let me, max depth parameter. If you come here, max depth, that should be slightly lower than single tree. Okay. What is the single tree max depth for this particular problem when you built the decision tree? What was your single tree max depth? Go ahead, check that and let me know. Go to the top, look at the decision tree. Tell me what is your single tree max depth. It was 9. So you can take something like either 8 or 7, something like 7 to 8 in this problem. Don't think that for all the problems you are going to take 7 to 8. Only for this problem, for this data, because 9 is the one. ETA, which is also known as learning rate, which is also known as shrinkage. What is the suggested range that I told you? Tell me, what is the suggested range for learning rate or shrinkage? 0.0001 to 0.1 is the suggested range that you can consider. Evaluation metrics. That means in the output, usually in the output some loss will be shown. That means the error will be shown. There are different type of losses available. But what we want to show in the output? Here I want to show error in the output, the usual error that we know. If the accuracy is 70%, error is 30%. If the accuracy is 80%, error is 20%. I want to show the error. Usually we use the term error for binary classification. For multi-class classification, we call it as multi-class classification error. So in the output, when this algorithm is running, iteration by iteration, what will be displayed to you? You will be getting multi-class classification error, or in simple terms, error rate will be displayed in the output. Okay. In the output, error will be displayed to you iteration by iteration. Tree method equal to GPU hist. This is the optional parameter that I'm talking about. XGBoost gives you an option to use GPU. So if you go to runtime, change runtime type. Here there are a couple of options. None means nothing. GPU graphics processing unit, TPU tensor processing unit. TPU is some kind of Google's own specific type of processing unit that they have come up. Outside world we will not get it. GPU is the one in other graphics cards and all that you will get. Don't change anything. because if you change this hardware accelerator, this whole notebook file will restart again. Anyway, it is GPU for us right now. Go to runtime, change runtime time. It is anyway GPU. So we will use GPU hist. This will make much faster. But unfortunately, Google Colab, it shows GPU is on, but since this is free, they don't really give us the real graphics cards or GPU. So if you pay something, if you use something called Collab Pro by paying 1200 per month to Google, then it will be really the real GPU. Otherwise, even though it takes this input, even though it displays that it is using GPU, in reality, GPU is not in use. It will take more time here. But in reality, if you are working on a real graphics card system, if you are working on paid version of Google Colab, then it will work much faster. However, the command is tree method GPU hist. This will use the GPU. Number of classes, how many output classes are there? Those need to be mentioned here. For a binary classification, it will be 2. But for us here, how many classes are there in the output? How many classes are there when you go to the target variable? There are 3 plus 3 plus 3. There are 9 classes. You have to mention that number here. These are all the parameters. These parameters will go to the XGBoost xgboost.fit or xgboost.train. Train is the function. Model.train. Take all those parameters. Along with them, take my data set, train data. Number of boosting rounds equal to 300, which means number of trees or number of iterations. Number of iterations are 300. Now, if the number of iterations are too many, what will happen? If the number of iterations are too many, what may happen? If that number is too high, we may get into overfitting. So how do you avoid overfitting? You can avoid overfitting by automatically stopping when you see that the test accuracy is not improving. Look at this. Early stopping rounds equal to 3. Stop after 3 rounds if the test error doesn't improve. So what this particular uh, command is going to do is this one. Where are we clustering now? Just give me a second. Posting, yeah. So if we say number of boosting rounds equal to 300, ideally it should run for 300 iterations, isn't it? Ideally it should run for 300 iterations. But we gave another condition called early stopping. You know what this early stopping will do? It will look at the train accuracy and test accuracy at every iteration. So 300 iterations means iteration 1, iteration 2, iteration 50, iteration 60, iteration 100, iteration 150, iteration 200, iteration 250. It will keep on running. Now, let's say accuracy increased on the train data, accuracy will keep on increasing because error keeps on reducing. That is the whole theory of boosting. We keep on reducing the error. We keep on building the model for the error. Accuracy keeps on increasing. Imagine that after 75 iterations on the test data, until here, the test data accuracy keeps on increasing. But at the 75th iteration, accuracy did not increase. It decreased. Wait for one more iteration. Accuracy did not increase, it decreased. Wait for one more. Accuracy did not increase. 3 consecutive iterations, the accuracy did not increase. Exit here. Stop early. How many iterations I told you? 300. Where did you stop? At 75th iteration itself you stopped. Why did you stop? Because I'm getting into overfitting zone. That is what early stopping is doing, which means when you give the number of boosting rounds, number of iterations, even you can give 1000, doesn't matter. Even if I give 1000 or 10,000, is there a guarantee that all these 10,000 iterations will be run? No. Early stopping rounds equal to 3, which means stop after 3 rounds if the test error doesn't improve. Test error did not improve, wait. Test error did not improve, wait. Test error did not improve. 3 consecutive iterations, the test error did not improve. That means the test error did not reduce. Then I can get a feeling that it is getting into the zone of overfitting. Whenever that happens, stop it. So take the train data, take the test data, do the verification, do the automatic stopping. That means even if you give 300 or 400 or 500 or 1000, it will be stopped much before that once we are entering into the overfitting zone. That is what this early stopping rounds is going to do. With all these conditions, if we give whatever time the boosting has taken, let's say 185 seconds, XGB will take exactly half of that. Strictly speaking, this is also not slow. 3 minutes is not a great deal, but I'm talking about the times 6, 7 years back. Our systems were not that fast. At that time, it used to take 40 minutes and all that. Then boosting XGB will take 20 minutes. But here, if it is taking 180 seconds, it will take now kind of 90 or 100 seconds. You will get the output for XGB. So keep it for the execution. Let us see how much time XGB takes. Go ahead, keep it for the execution, all of you. How much time does XGB take? It is still executing in my system. Check. Roughly 90 seconds or something, almost half the time will take. But if GPU is also effective, it takes 8 or 9 seconds, that's it. So I have used Colab Pro for some time. There, when I have tested this algorithm from 180 seconds, it'll take like 8 or 9 seconds. XGB, as soon as you execute, within 8 or 9 seconds, you'll get the result. So 83 seconds in my system, it happened like I got the result in around from 185 to 83 seconds. That is the difference between XGB and GBM. XGB is the only model that is used. A lot of people are not even aware of GBM. You can ignore GBM also in future. XGB will be the model that you are supposed to use and fit. Nowadays, almost all the laptops are actually coming with a graphics card, isn't it? At least 2 GB graphics card is there. So you can always use that graphics card here to run this much faster. As soon as you use graphics card, what XGB does is it breaks the computation into smaller pieces, tries to send all the values to the smaller calculation to the graphics cards, and parallel processing is the one that will happen. Early stopping rounds, let us go through it once again. Let's wait for everyone to complete this. Then I'll explain these early stopping rounds once again. So to understand early stopping rounds, let us have a kind of dialogue. Let's say if I give number of boosting rounds, which means number of iterations, as a very high number, let's say 1000 or 2000 or 3000 like that. If I give too high a number, what will happen to my final XGB model? What will happen to this model? What is the risk if I run it for too many iterations? Think about it. If the number of iterations are too many, what may happen? It will definitely overfit. If you are giving too many iterations, your model is going to overfit. Then, if we are giving too few iterations, what may happen to our model? It will underfit. So we have to stop at an optimal point. But if we are giving the number of iterations as 2000 or let's say 500, the model will keep on building. On the train data, the model will keep on building. It will start from iteration number 1 until iteration 500. It will keep on going. And at every iteration, the error keeps on reducing, the accuracy keeps on increasing. But I have to stop to avoid overfitting. I have to stop when I start this overfitting. When I'm starting to enter this overfitting zone, we have to stop here, isn't it? First, I'll answer this question. I'll come to your question, Venkat. Huh? So, when we want to avoid overfitting, we have to stop this at an early point. For stopping it at an early point, what we are doing is we are giving the test data also to the model. Okay. What we are telling the model to do, at every iteration, look at the accuracy on trained data, look at the accuracy on test data. Go to the next iteration, accuracy on trained data is bound to increase because this is boosting procedure. Accuracy on trained data will increase. Is the accuracy on test data also increasing? Very good. Let's say until 90 iterations, it happened that accuracy on trained data kept on increasing. In the 91 iteration also, accuracy on trained data has increased. That is bound to happen. But on the test data, what I have observed is accuracy on the test data did not increase, it decreased slightly. Is that a sign of danger? Well, think about it. From 90 to 91st iteration, accuracy on trained data increased, but accuracy on test data decreased. Maybe this is just an aberration. Once in a while it does happen. Maybe 1 or 2 times it may happen that it may decrease, it may fall back into the track. That's why once it got decreased, I have waited for one more iteration. Accuracy 91, from 92 iteration, accuracy on trained data increased. On test data, it again got decreased slightly. I'll wait for one more iteration. Accuracy on trained data increased, accuracy on test data again decreased slightly. 3 times consecutively, accuracy on test data decreased. Is it fair enough to say this is definitely overfitting zone? I should not run for 500 iterations. I should stop at 90 iterations. Does it make sense to stop at 90 iterations here? Think about it. That is called as early stopping. So if we give this option of early stopping and the early stopping rounds is 3, it means that stop after 3 rounds if the test error doesn't improve. That means every round you keep on looking at the test error. If the test error, or from the accuracy point of view we discuss, if the test accuracy does not improve, test accuracy does not increase, stop early. Though I have given 2000 or 1000 iterations here, did it really run 1000 iterations? It stopped after 50th iteration. What could be the reason for stopping after 50th iteration? What is the reason? The reason is after 50th iteration, it observed that the test error is not improving. That is why it stopped. That's what early stopping means. Early stopping means not necessarily running all the iterations. Okay. Is it clear? Make sense? Yeah. Let's take the next question. What is the simplest way to know the modest number of iterations? Modest means you mean to say optimal number of iterations, is it? Optimal. Yeah, this is the way. Give a slightly higher number, use early stopping. Okay. This will take care of it automatically. Have you got this method, Venkata? Have you understood this method of stopping at the optimal number of iterations? Is it confusing or is it clear? Yeah. Well, that is the story of boosting. In conclusion, what I can tell you is random forest and boosting, they are a different class of algorithms. Linear regression, logistic regression, decision trees, cluster analysis, these are known as classical machine learning algorithms. People have used it for 30 years, okay, nearly from 1995 onwards till 2015. People have used them. Okay. But from 1990 onwards, ever since the computers came in, Excel came in, etc., etc., people have started using them. People, though there is a theory around random forest and boosting, people did not really use them because of the lack of computation power. When I first started giving these trainings, I'm talking about 2015, 2016, during that time, random forest exercise and boosting exercise each used to take nearly 40 minutes. Boosting exercise used to take 45 minutes. Same data sets, but they used to take a lot of time. So just before the lunch break, we used to execute this. There used to be a very big problem. So I used to plan that I'm not taking these two sessions on the same day. So we used to keep it for execution and take a larger break and then come back and see the result. That was the scenario back then. But nowadays we got better systems. We have cloud infrastructure, we have GPUs, etc. We can execute all this. So I have seen that industry have started experimenting with these black box methods as well. People have started slowly using this. That is the reason why most of the applications, most of the problems are being solved. That's the reason why ML became very famous, isn't it? Especially the buzz is around last 5 years only. From past 2016 or 17 onwards, there is a huge buzz because of this. Like we can actually solve very, very complex with simple commodity software that is available to us. So now in future also in this, there are better systems that are coming up, better algorithms are also coming up. It's a very exciting field to be in. That is the story of boosting. Any final questions anyone have? Let us see what are our next steps. What did we learn? What did we learn? We started with some Python basics. Python basics. Let me tell you honestly, I did not go very much in depth into Python because your company wants us to give a basic introduction to Python only. In a 3-day program like this, there is no point in dedicating one full day for a programming language. So if you are really interested, you may have to explore more, okay, on Python. Then we went on to discuss basic stats. These are sufficient to get started with machine learning. Then we discussed linear regression. We have discussed very much all length and breadth of linear regression. You should be able to handle a regression project for sure. Same thing goes with logistic regression. Decision trees also, you must be able to handle any level of projects with real data. Random forest, anyway, we have taken a real competition data. Boosting is also same way. And then there is a special one in between, cluster analysis. Once again, let me quickly recap. What is the cluster analysis? What is the speciality of it? We need to be slightly careful with cluster analysis. What is it? This is a clustering is a, it's very different from rest all guys. What is this? Clustering is a unsupervised machine learning technique, which means validation is not possible. Okay, we need to be aware of it. Obviously, this whole machine learning, data science is an ocean. These 3 days, what I have done is I have given you a starting point. It is not true that everyone in the classroom will work on all these algorithms. It is not true. Some of you may be working only on regression. Some of you may be working only on customer segmentation for next 1 year. Some of you may be working only on random forest and boosting. Some of you may be working only on logistic. Whichever is the project that you will get, you have all the knowledge right now ready with you. You should be able to handle that project. But the remaining things on the job, while you are working, you may have to explore more and understand. This is a kind of solid base. This is a starting push that I have given. Remaining things you are going to add on your own. So if you ask me, are there any good reference books? The books that have found useful. This is world famous book, very, very famous. An introduction to Statistical learning, very practical, applied book with applications in R and Python. They have given the code on their GitHub. Both R and Python is given. It is written by Gareth James, Daniela Witten, Trevor Hasty, Robert Tripshirani. These are the true professors who are very famous. If you have liked my course here, the way that we have discussed, then you can refer to my book as well, Machine Learning using Python. It's available on Flipkart as well, okay, as well as Amazon. Pretty much almost some of the examples, some of the discussion will be kind of, you will find it repetitive. The same thing were discussed there as well. But there will be a lot of theory in this. Along with the applications will be anywhere there. Practical aspects will be anywhere discussed. But this is referred by several universities. So there we have to include the theory as well. Theory part, if you are interested, you can see. Otherwise, you can ignore that as well. Okay. These are some of the practical books that you can refer to. Some of you might be interested in video courses. So this particular slides that I'm showing, I'm going to attach these in the classroom. So you don't need to really take a note of this. These are all the links. These are all the ML courses from Coursera. Like there are so many courses. I think you are also aware of it. If you go to YouTube, hell lot of courses will be there. These are kind of curated ones. In the sense, I have gone through several courses. After going through these some of the sample classes, after reading their material, I found that these 10 courses are pretty useful. You may find these courses. Some of them are paid, some of them are kind of free. This whole PPT itself, I will share this in the classroom. Okay. In this PPT, you have this link. Okay. Yeah. So like if you click on this link, it will automatically take it there. Like this is the first course like that. Okay. Those are some of the courses. If you have liked this training, what I do is on the weekends, I run a very lengthy batch for almost like one full semester machine learning course that I run. That is not a 3-day course like this. It goes on for 4 months. The major difference would be there will be a lot of assignments, quiz questions. It will be like a proper one semester course. So if any of your friends or colleagues who are looking for data science or machine learning classes, if you have liked this, you can tell them your feedback and you can suggest my course to them. So it will be, but make sure that they have to dedicate at least 4 months time for this. Some of you may be interested in getting the data sets. Kaggle is one best place to get any data set in this world. If you are a data scientist, the rule is you must have a login ID on Kaggle. It is that important. You know that? It's free. Kaggle is free. It's owned by Google. If you click on data sets, hell lot of data sets are available here. Somebody was asking, can I get anything related to telco? Do you have any telco related examples? Simply type telco, you will get 60 data sets. Telco customer churn is one data set. Telco customer churn IBM data set. Different data set. Telco churn, applied ML courses on telco churn, telco euphoria. Different, type of data sets. What is the beauty of this? Let's say I have clicked on this telco customer churn. It's not just about downloading the data. When you go here, there's something called code. 737 code files are given here. So somebody has written code for light GBM. He has used XGBoost for solving this problem. So you can click on this. You can read his code. Sometimes some of these are pretty well written. So somebody has given a complete details, etc., and all that. See the visualizations. Beautiful visualizations are also given. And you know what is the best thing? You don't even need to copy this code. Simply click on this copy and edit. You can execute this code. That means if you want to get started, this is like one of the fastest way to make our hands dirty. This is a pretty good resource. All types of data sets. Okay, I'm not interested in telco. Are you interested in healthcare? Okay, healthcare. Okay. Healthcare data sets. Do I have any healthcare data sets? Healthcare. 597 data sets are there. Healthcare. Heart attack possibility. Healthcare analytics. Healthcare provider. No, I'm interested in insurance. Okay. Can I get something related to all types of industry? Everything is here. If you utilize it carefully, you will be at least busy for next 2 years. This is a huge resource, and so many code files will be there. Somebody has built another model. Let us see, somebody has built a boosted model. Some people, most of the people will do EDA, exploratory data analysis. They'll just do the data exploration and leave it. Okay. Some people will do, let's say, decision tree, XGBoost, registration, like that. Okay. Anything. XGBoost. Yeah. So you can go through these code files and then copy this and you can save your own version. The best thing that I suggest is copy the code, make only small changes to this code. Okay. Do not try to write the whole code from the beginning. Try to make some small changes this code and then see whether it is working or not. Later on, slowly, whichever is your interest, take a data set, try to solve that problem, publish it here, try to follow that method. Okay. It's a pretty good resource. I use a lot of data sets from Kaggle because most of them are real data sets. Those are real challenges. Only thing that I do is before bringing into the class, I just clean the data a little bit because data cleaning is a time consuming process that is not really going to add a lot of value if we are discussing data cleaning everywhere for every problem in the classroom. So if you ask me, what is your next 2 year plan? Okay. So maybe I can suggest this 2 year plan for you. If you are interested in data science, if you have understood whatever we discussed in the classroom, if you want to become a perfect expert data scientist, okay, to reach, like maybe you are at a beginner to intermediate level. If you want to get into a expert level, this is the path you must follow. Take any of the online course, okay, in the online courses that I have shown. Make sure that it is a full 1 semester course, not a short-term course, okay, and do all those classroom exercises. So since you will be working, it will take, instead of 3 months, it will take 6 months for you. Take any of the industry problems from Kaggle, stick to one industry that you are interested in, do some of the at least 5 6 problems, like try like 5 problems on regression, 5 problems on logisticization, 5 problems on decision trees, like that. 6 months you practice on Kaggle. After that, maybe some more theory you may be interested in. Once the applications are covered, then you can read the books and the theory that you can focus on 6 months. And then the one that really helped me is, while you are learning, think in such a way that you are going to teach someone else later on. You're going to somehow explain this to someone else. Then you will be learning with much more care. Okay. Something like if you're solving a puzzle, sometimes that is easy. But if you are creating a puzzle, you will learn a lot, isn't it? If you are the person who has to create a puzzle, then you will be covering a hell lot of puzzles. You will be solving so many more puzzles to create a puzzle, something like that. Try to republish, maybe try to write blog posts or try to upload the code files onto Kaggle, or try republishing as well. That will be the final ultimate way of testing whether we have understood this or not. Then you can participate in the discussions and all those on Kaggle itself in the comment section. So this is a suggested plan. Obviously, this is not a rule. You can take from here few of the things from here. So that is it from my side. I hope on the first day I told you that I'm trying to make machine learning easy. I hope I have succeeded in that. I would like to know what is your open feedback. Anybody, how did you find this course? How was your experience? Past 3 days, how they have been? Any open feedback is. Anyone? who would like to share?
It was really insightful and I learned a lot. So thanks for that.
It was a really good session. Your teaching style is very nice, so I've learned a lot of things.
Thank you. Let me share my contact details. So you can actually add me on LinkedIn. You can search on Venkata Reddy Konasani, my full name. This will be my profile. You can always add me on LinkedIn. Statinfo.com is my company. There also you can send a mail, venkat@statinfo.com. 21.venkat@gmail.com. You can always send a mail or you can send a message on LinkedIn as well. I'll try to be available as much as possible. It's perfectly fine in future if you have any questions, if you want any clarifications, or in future, if you are searching for a material, if you think that that material will be available with me, you can always send me a mail. I'm not really a person who will shy away, and this material can be used. If I'll be in fact much more happy if somebody is finding my material helpful. It's even perfectly fine if you want to take my material, give it to another trainer, ask him to teach somewhere else. That is also I'm very happy. You can also share this material with anyone else. Okay? It is your final chance to ask any more questions, anybody, any more doubts or any more general questions are also fine. Please go ahead. What about data preparation algorithms? Are there any data preparation algorithms as such?
Yeah, honestly, sorry about that confusing question. So usually,
Okay.
what couple of use cases I have seen is right. So though they will have some 15-20% of the data. Okay,
Yeah.
so they will generate some data, which will mix up. It's not to mix up is the right word, but they will enlarge the data up to some extent to make it realistic up to 60 or 70%. So till now, what we have seen is the data parsing and not data parsing from the we use the generated data. So uh, so such kind of things also will come under this machine learning, or is it a separate uh,
Part of it is kind of little bit mixed here. Not 100% of that comes under here.
mm,
Most of it goes under data collection.
mm,
There is a technique called synthetic sample generation. It is known as SMORT technique.
mm,
And there are few techniques called oversampling. That means something like bootstrap sampling that we did, right? Oversampling, undersampling.
mm,
But yes, I think the nearest one would be SMORT, which is a specific algorithm. Let's say if you have customer one, his age is 25, and if you have customer two, his age is 24. Okay.
mm,
And this guy seems to be a non-buyer. This guy seems to be a non-buyer. In smart technique, what it does is it will create customer 3, which was never there. His age will be given as 24.5, and he is also seen as non-buyer. This kind of data is generated. You synthetic sample, this is known as. Okay. That is the nearest way of data preparation or like data creation, I would say. But usually we tend to avoid unless until it is a great requirement. When this kind of smart technique is used, sometimes you have very, very rare events. Let's say if I take 1 million transactions, out of them, only one transaction will be fraud. Remaining all 99,999,000, these many transactions will be non-fraud. Okay. In those cases, I would like to increase this. That means I want to try to take oversample this. That means I want to take the duplicates of this and also create the new data points. Okay. Otherwise, data is a factual information. We are not supposed to do anything. It's almost like I'm creating the data and I'm building the model for it. That can be avoided most of the times.
Okay, thanks.
So the question is, when I checked on Udemy, on Coursera, I found courses for data scientist, data analyst, could not understand which one to choose. So my suggestion would be, rather than the course title, try to look at the course contents. Okay. So we have right now we have discussed, you can think this as machine learning intermediate. Until here we have discussed. Maybe you can choose the course that is covering most of the contents in this course right now, whatever we discussed, and in and around that. Okay. Then you can take that course and try to complete it. The name can be anything, be it data scientist or the data analyst. Okay. The contents, whatever we covered here, in and around that, little bit more than that, you can take such courses. But as it is in the outside world, when people refer to a data analyst, nowadays I'm saying, they tend to refer it to as a reporting analyst. They are just doing the visualizations and creating the reports. Data scientist is a kind of somebody who is building machine learning models and all that. But the courses, the actual contents will decide what is the right one.
Actually, I had a doubt on XG boost.
Yeah, please go ahead.
Yeah, from the example, like in the lab example,
Yeah.
the accuracy is slightly lower than the GBM method.
Significantly or
No,
just
no,
1 or 2?
slightly,
Then we can
20%.
ignore. Usually, even GBM also, if I retake the train data, within that 1 or 2% with large data, you will always see. Okay.
Okay, okay.
Always you will see 1 or 2% difference with most of the data sets. But when this difference is huge, then we have to worry about that. Okay.
But it's usually preferred that we go with the XG boost, is it?
We don't build GBM models in general.
Oh, okay, okay, okay. Got it. Thanks.
Without the skills on data science, can I take up data analyst course. Right now, if you ask me honestly, this data analyst, this data scientist, these are kind of mixed up. Both, like, lot of topics are mixed up. So let me use this way. Data analyst means reporting analyst, which means like he does maybe he uses data visualization tool like Tableau. He does SQL, and then MIS reporting using SQL. Maybe use Excel for ad hoc reporting, etc. Data scientist is using some kind of machine learning models like logistic regression, linear regression, decision trees. If we understand from that point of view, so without these skills, is it okay to learn this? Yeah, it's a kind of organic way of doing the things. First, be a good reporting analyst, and then this is kind of descriptive analysis, trying to tell whatever is there, and then getting into predictive. Yeah, it is possible. Some of the courses are good, but the problem right now in the outside world, a lot of students, what they shared with me is, it's like the outside world is overwhelming. There are like too many options. Earlier, we have an issue of less information. Now the problem is, like, once you go to Google, there are so many courses. Once you type data science course, you will be bombarded with so many ads, isn't it? In fact, on the first page, very less results will be there, more ads will be there. So out of this, how do I choose the best course? That is the biggest challenge right now for a lot of people, isn't it? Like, even after a lot of sorting, if we choose the course, if they are teaching us only theoretical concepts, like in a pure academic style, that's not going to really help us, because once we take the data, the steps that we follow are very, very, different from what we learn in academics. We should know what are the practical aspects of it. So carefully, we have to choose a course that covers mostly practical data sets, and it also should cover practical tips and tricks. Any other connected questions, anyone? Well, if there are no more questions, that is it. All the best, everyone. Once again, thank you for interacting with me in the chat window. I wish you all the best, and one day I'll see you in the office premises. If you have any questions, please stay back. Otherwise, you can drop off. Thank you once again.
Hey, I have one question. It's
Yeah,
I'm
please go
not
ahead.
sure whether it's related to data science or related to this. Sorry about that. See, we have a product A, okay, and we
Okay.
have a product B, okay.
Okay. Yeah.
So we want to migrate the customers from product A to product B, okay.
Okay.
So the product A features
Mm.
may not be available in product B.
Okay.
So like that, so there would be many customers. So there will be many customers, and they'll be using many features of the product, and that product, that features may have some interdependent features, and they may not be available in the product B. So now let's say, I'll get that report. Okay, these are the customers, these are all they using these products, and that these are all the features they are using. So for that, so what I am planning is to get a list of customers with the products with individual features they are working on. And finally, I should be able to, show, okay, what is the percentage of ratio that this customer can be successfully migrated to product B. So that is the some kind of POC I want to do. So with respect to that problem, so it's right now I'm planning to do in a programmatic approach. Like programmatic approaches,
Yeah.
we just have some lookup data with okay, this feature, yes, no, yes, no, yes, no, so gather some that kind of data,
Yeah.
and give some kind of rating for all these features or whatever it is, and
Okay.
then get it as some derive one value. So is that the way we should do, or I'm slightly confused whether any of these algorithms which we discussed today we can apply here.
So to apply these algorithms, first we need to define the problem statement. Okay. Right now,
Mm-hmm.
you have the problem statement in hand, but
Yeah.
you have to make it
Mm-hmm.
into the structure of the machine learning problem. That
Okay.
means,
Okay.
what is your target? Let's
Mm-hmm.
imagine the target is predicting whether
Yeah.
the customer will take product
Mm-hmm.
B or not. Okay. Or
Right.
product A or not. That is the target.
Yeah.
To take this, okay, to take this particular product, what are the features? So features X1, X2, maybe they are available, maybe they are not available, that is secondary. For
Okay.
somebody to take this feature, for
Mm-hmm.
somebody to take this product,
Mm-hmm.
what are the features that will help me to predict this? Okay.
Mm-hmm.
Do you think the age of the customer, just for the discussion sake, I'm saying, do you
Mm-hmm.
think the age of the customer will dependent on that? Or do you think the customer relationship, the number of years he has been with us, is it dependent on that? Like that, you have to
Mm-hmm.
first convert it into a machine learning problem.
Mm-hmm.
The problem, current problem that you have, the
Mm-hmm.
X1, X2, X3, what are the features that shall be used for the prediction of target? What is the target? What
Mm-hmm.
are the features? Once you have this first created, that
Mm-hmm.
means you are giving a structure to a problem.
Mm-hmm.
Then, even if you build your first model, let's say logistic regression line, even if it is giving 55% accuracy, that is our first level of success. From next
Okay.
time onwards, what you will be doing is
Mm-hmm.
bringing more and more such features that will influence this. Then you can push this one day from 55 to 80 and 85. Yeah. So your first task would be somehow coming up with this list of features and coming up with this target and showing it as a predictive problem.
Okay. So
Yeah.
basically, this is X1, X2 are nothing but the features of the product.
Features of the product and the types or the customer, what do you call, characteristics of the customers who are likely to take product B.
Mhm. Okay.
Characteristics. Features of the products. If this feature is there, then the customer will take. That is from the product point of view. From the customer point of view, also you have to put what kind of customers are likely to take what of them.
Okay. 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 Not only just product. Yeah. Right.
Mhm. Or sometimes we tend to
Mhm.
include time related, like in a
Mhm.
particular time, people are going for a particular product. Okay. Like that.
Okay. Okay. Yeah.
Uh, Hi, Venkat, this is Vidya here. So I wanted to take up this data analysis course because the products that I work on don't expect that I, work on the algorithms or the, do the data science part, but that's already done at the product end because it's all AI driven.
Okay.
Now my requirement is to be able to understand it and to be able to show it to the customer. Because the reason for me asking about telecom example is because most often we work with teleco customers and they have humongous amount of data. But the problem is even the algorithms that we have are not able to put it into a proper structured format. And even when we go back to the product team, all that we often hear is the data is not clean, the data is not directly usable and all that. So we didn't really have any good outcome from that data. And that's not about, and that's like, they have a huge amount of data, like a million records for a few months also. So how do we get about this? And in fact, the product is called Watson AI Ops and Netcool Operations Insight. So and I wanted to complement my experience by learning the data analysis tools. So that's why I kept asking you about data analysis. And this is one course that I found on Coursera. And in fact, one of it I had already enrolled even before I joined this training. So what is your thought about this course? Or if there is anything that is better, please advise me as well.
I think data analysis or data visualizations, mostly you want to go for reporting analytics and storytelling, isn't it?
Correct, yes.
Reporting analytics and data is huge. And
Mm.
then from there, you want to show your insights to the customer in such a way that they can understand the full details. Yeah, reporting analytics, data visualizations. Okay.
Right.
You can take these type of courses. It will be complementary to whatever you're working on.
Okay.
Usually when you have humongous data, like let's say even in credit cards, if you take the credit card transactional data, we used to have millions and millions of transactions, isn't it?
Mm.
How do we used to handle it? We don't work with transaction level data. If we have a large data set, either we sample it, because sample generally represents the full data. The patterns in the sample, mostly they match with the patterns in the full data, most of the cases. Okay.
Okay.
Either we sample it or we aggregate it. We have so many transactions aggregated at each customer level, number of transactions in a month, or maybe time or a monthly level. Like that, let's say if data size is the only problem, quickly you want to generate insights, either sample or do the aggregation, get the insights, then you can do the drill down on a particular segment or a particular data. Okay. Otherwise, these reporting analytics and data visualization courses, they will teach how to tell the story from the data.
Okay. Okay. So this course that I found on it's on Google Data Analytics. So is
Yeah.
this a good one to take? Or if I am working on any IBM tool, say for example, are there any I mean, should I avoid this and take up anything which is related to IBM tools only? I mean, I'm completely new to this, so I'm just trying to
I
understand.
think you can take general data analysis because IBM is not the final destiny. You want to upgrade the skill
Mm.
as such, isn't it?
Yeah.
So, and use that skill in solving this IBM problem. So, general data analytics course, it's better to take and then apply those techniques here to solve the problems here.
Okay. 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 Sure. Okay. Thank you. Thanks. Okay, thank you so much, Venkat. I'll drop off. It was a great session. I mean, when I started off this session, I had literally not even the basic knowledge of it, but now I think you've given a quite insightful session, especially with the examples. Thank you so much.
Sure. Yeah, all the best.
Yeah, bye-bye.
Yeah, thanks. Venkat. So for me also, it is very big. I was literally, honestly, it was my first session on machine learning.
Okay.
So at least, now I know. So at least I'm just started this journey in my career. So very thankful for that.
All the best, Sudhakar.
Thank you.